berjalan, gemersik daun bersapaan, menciptakan melodi, tenangkan hati, menemani tapak kecil dalam menggapai mimpi. Disinilah ku berada, tempat nasyunan rinda. Aku dan semua mimpi jiwa muda berprestasi, melahirkan nilai yang agung. Aku dan semua mimpi jiwa muda berprestasi, dan ku harap barisan unggul. Disinilah ku berada, di tempat nasyunan rinda.
Selamat datang di Universitas Negeri Semarang, kampus berwawasan konservasi, bereputasi internasional, mencetak generasi unggul, cerdas, berkarakter. UNES adalah rumah ilmu pengembang peradaban yang dikelola dengan standar bereputasi internasional. Bersama UNES, kita tunjukkan kepada dunia pendidikan Indonesia yang bermutu.
Aku dan semua mimpi jiwa muda berprestasi, jadi insan berbudaya. Aku dan semua mimpi jiwa muda berprestasi, semangat dan terus berkarya. Dari aku untuk Indonesiaku, UNES cerdas untuk Indonesia
Assalamualaikum warahmatullahi wabarakatuh. Good morning. Greetings to all of us. The Honorable Rector of Universitas Negeri Semarang, Profesor Dr. Fatur Rahman, M.Hum.
The Honorable, the Vice Rectors in Universitas Negeri Semarang.
The Honorable Dean of the Faculty of Engineering, Universitas Negeri Semarang, Profesor Dr. Nur Kudus.
The Honorable, the Deans in all faculties in Universitas Negeri Semarang.
The Honorable the heads of all institutes in Universitas Negeri Semarang,
the Honorable, all Vice Dean in the Faculty of Engineering, Universitas Negeri Semarang, the Honorable, all heads of the department and all the heads of the programs,
the Honorable Chairperson of the Engineering International Conference 2022, Dr. Muhammad Faisal Ardiansah Arifin, PhD. The Honorable, the distinguished keynote speakers of the 11th Engineering International Conference,
Professor Dr. Ismail Saad from University Malaysia Sabah,
Professor Nor Azwadi bin C. Siddiq, PhD, from University Teknologi Malaysia,
Professor Ong Huai Chuan, PhD from National Yunlin University of Science and Technology,
and Professor Agung Budi Wirawan, PhD, from Universitas Negeri Semarang. Welcome to all participants in the 11th Engineering International Conference 2022. First of all, let us praise the presence of Allah Subhanahu wa Ta'ala for all His blessings and gifts, so that today we can gather in good health without lacking anything.
please allow us as Master of Ceremony to introduce ourselves. I am Ahmad Wildan Liavilla from the Civil Engineering 2021 study program, and my partner,
I'm Syadza Ardia Rihadatulaisi from the Civil Engineering 2020 study program, who will guide the 11th Engineering International Conference 2022.
distinguished guests, we as the Master of Ceremony will read out the schedule of the event.
First, opening.
Second, singing the Indonesian national anthem.
Third, report of the chairman of the committee and remarks.
Fourth, photo session.
Fifth, keynote presentation.
Sixth, break.
Seventh, parallel session.
And eighth, closing.
First, let's open this event by reciting Basmalah together. Bismillahirrahmanirrahim. Hopefully, with the Basmalah reading earlier, this event will run smoothly, and the knowledge that we get later can provide great benefits for all of us. Amen.
The next event is singing the national anthem, Indonesia Raya. The audience is asked to stand up. Thank you, ladies and gentlemen. Please be seated again.
The next event is the report of the chairman of the committee, which will be delivered by Dr. Muhammad Faisal Ardiansah Arifin, PhD. To Dr. Muhammad Faisal Ardiansah Arifin, the time is yours.
The Honorable Professor Faktur Rahman, Rector of Universitas Negeri Semarang. The Dean of Engineering Faculty, Professor Dr. Nur Kudus, all of the Vice Dean of Engineering Faculty, and all deans in faculty in Universitas Negeri Semarang. And the distinguished keynote speakers today, Professor Dr. Nur Aswadi, Professor Ismail Saad, Professor Dr. Agung Budi Wirawan, and Professor Ong Hwee Chuan, who are willing to come in these very special occasions, and the honorable of invited audience and participants. Assalamualaikum warahmatullahi wabarakatuh. First of all, let's pray and thanks unto our God Allah Subhanahu wa Ta'ala, who has been giving us some mercies and blessing so that we can attend and gather in this place in good condition. I, Dr. Muhammad Faisal Ardiansah Arifin, on behalf of the 11th Engineering International Committee, feel an honor to stand here to address such distinguished participants and audiences. I would like to welcome you to Semarang and 11th Engineering International Conference on Applied Green Technology for Environment Conservation through Continuous Engineering Innovation. Your participation in this annual international conference is highly appreciated. This conference is conducted by Engineering Faculty of Universitas Negeri Semarang to address environmental deterioration issue. Therefore, the 11th Engineering International Conference is aimed to providing discussion platform for engineers, academicians, industrial practitioners, educators, and government officials to foster the growth of environmentally friendly technology. Finally, I would like to thank to Engineering International Committee of Engineering Faculty for managing this conference. I do expect that this annual conference could provide such beneficial insight for the participants. That's all for me. Thank you for your attention and participation. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you to Dr. Muhammad Faisal Ardiansah Arifin for presenting the report.
The next event is a speech as well as the opening of today's conference by Vice Dean of Academic Faculty of Engineering Universitas Negeri Semarang, Dr. Didik Prastianto. To Dr. Didik Prastianto, the time is yours.
Assalamualaikum warahmatullahi wabarakatuh. First of all, I would say a warm welcome from Rector of Universitas Negeri Semarang and the Dean of Faculty of Engineering Faculty, UNES, to all keynote speaker, all distinguished guests, and all participants of the 11th Engineering International Conference. Our Rector, Professor Dr. Faktur Rahman, would like to open this event personally, but unfortunately, he have to attend UNES graduation ceremony. I would like to thank to the keynote speaker, Dr. Ismail Said from University Malaysia Sabah, Professor Dr. Nur Aswadi bin Siddiq University from University Technology Malaysia, and also Professor Huai Chun On from National Yulin University of Science and Technology Taiwan. And the last is Dr. Agung Budi Wirawan from Universitas Negeri Semarang. Today we will have a special event, this 11th Engineering International Conference. We hope that in this conference we will strengthen our collaboration, and also we will strengthen our network, especially in our green technology. In line with our mission, our UNES vision as a conservation insight university with the international reputation, and also our spirit of UNES, house of knowledge, developing the culture, we proudly conduct this conference with the theme applied green technology for environment conservation through continuous engineering innovation. UNES continuously develop engineering innovation on conservation of the nature and green technology to make a better quality of a human life. Here that we work together. We work together to achieve a sustainable development goal such as sustainable cities and community, and also affordable and clean source of technology. We as an engineer have a main player role to realize the achieve of the sustainable development goal. Nowadays, the implementation of green technology is a way to achieve this goal. So we will make this this green technology for the better future. I would like to close this opening speech by a quote from John McCain. Suppose that climate change is not real, and all we do is adopt green technology, which our economy and our technology is perfectly capable of. Then all we have done is given our kid a cleaner world. By saying Bismillahirrahmanirrahim, I officially open in the 11th Engineering International Conference 2022. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Dr. Didik Prastianto, for the remarks given. The next event is a photo session. The attendants are requested to activate the camera to document today's activity.
Documentation begins. First slide. 1, 2, 3.
Then the second slide. 1, 2, 3.
The third slide. 1, 2, 3.
Thank you.
Thank you to the invited guests who have attended the 11th Engineering International Conference 2022. For invited guests who have other agenda are welcome to leave the Zoom meeting, but we hope that the invited guests will continue to follow the event until the end.
Terletak di kampus utama Universitas Negeri Semarang, Fakultas Teknik merupakan fakultas kelima sepanjang berdirinya kampus Universitas Negeri Semarang sebagai rumah ilmu yang menyelenggarakan pendidikan tinggi dalam ilmu pendidikan teknik, pendidikan vokasi, dan ilmu rekayasa. Fakultas Teknik semakin meneguhkan posisinya menjadi kampus besar perguruan tinggi yang menghasilkan insan cendekia yang kreatif, kompetitif, dan inovatif, baik dalam bidang akademik maupun non-akademik, untuk kemajuan bangsa dan masyarakat dunia dengan berbagai penghargaan dan capaian prestasi dalam skala nasional maupun internasional.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Fakultas Teknik Universitas Negeri Semarang mempunyai visi menjadi fakultas yang berwawasan konservasi dan bereputasi internasional. Fakultas Teknik menyelenggarakan pendidikan, penelitian, dan pengabdian kepada masyarakat dalam bidang pendidikan teknik, pendidikan vokasi, dan ilmu rekayasa. Kami terus berupaya dan berkomitmen menghasilkan lulusan unggul yang beriman, profesional, serta mampu bersaing dalam dunia kerja dan menjadi unggul dalam bidangnya untuk membangun bangsa dan berguna bagi semua masyarakat dunia.
Fakultas Teknik Prestatif.
Fakultas Teknik Kreatif.
Fakultas Teknik Profesional.
Selamat datang di Fakultas Teknik Universitas Negeri Semarang.
Fakultas Teknik Universitas Negeri Semarang memiliki 5 jurusan yang di dalamnya terdapat 14 program studi, 9 program studi kependidikan, dan 5 program studi non-kependidikan. Jurusan Teknik Sipil memiliki 3 program studi, yaitu Program Studi Pendidikan Teknik Bangunan, Program Studi Teknik Sipil, dan Program Studi Teknik Arsitektur. Jurusan Teknik Mesin memiliki 3 program studi, yaitu Program Studi Pendidikan Teknik Mesin, Program Studi Pendidikan Teknik Otomotif, dan Program Studi Teknik Mesin. Jurusan Teknik Elektro memiliki 3 program studi, yaitu Program Studi Pendidikan Teknik Elektro, program studi pendidikan teknik informatika dan komputer, dan program studi teknik elektro. Jurusan pendidikan kesejahteraan keluarga memiliki 4 program studi, yaitu program studi pendidikan kesejahteraan keluarga, program studi pendidikan tata boga, program studi pendidikan tata busana, dan program studi pendidikan tata kecantikan. Jurusan teknik kimia memiliki 1 program studi, yaitu teknik kimia. Masing-masing jurusan didukung dengan laboratorium belajar yang berorientasi industri sebagai sarana pengembangan kemampuan-kemampuan akademik mahasiswa untuk siap terjun dalam dunia kerja. Fakultas Teknik Universitas Negeri Semarang memiliki 14 program studi yang sudah terakreditasi baik dan unggul. Berbagai prestasi telah ditorehkan oleh mahasiswa Fakultas Teknik Universitas Negeri Semarang di kancah internasional, diantaranya Finalist of Cell Eco Marathon Asia, Finalist of Same Car Competition Jerman, gelar karya Fakultas Teknik Universitas Negeri Semarang, the second winner of International High Early Strength Cell Consolidating Concrete Cube Competition, yaitu lomba beton tingkat internasional, gold medal dalam event kompetisi penemuan dan inovasi internasional Sahasak Nimafum di Sri Lanka. Prestasi terbaik Fakultas Teknik Universitas Negeri Semarang yang lain diantaranya Papermob terbaik Fakultas Universitas Negeri Semarang 2019, rekor muri Papermob virtual pertama di Indonesia.
Nggak tahu.
Pencapaian ini menghantarkan Fakultas Teknik Universitas Negeri Semarang sebagai fakultas yang memiliki kredibilitas baik dan unggul. Organisasi kemahasiswaan yang berada di Fakultas Teknik yaitu Lembaga Kemahasiswaan di tingkat fakultas dan jurusan, Badan Semi Otonom, dan Wadah Aspirasi.
Prodi Teknik Sipil Universitas Negeri Semarang mulai terbentuk pada tahun 2012. Prodi ini memiliki beberapa sumber daya manusia yang berkompeten dengan memiliki ijazah sarjana S3 dan sarjana S2. Visi dari program studi Teknik Sipil Universitas Negeri Semarang adalah menjadi program studi berwawasan konservasi dan bereputasi internasional. Kami di Prodi Teknik Sipil memiliki berbagai macam laboratorium yang berfungsi untuk menunjang dan mensupport segala kebutuhan belajar mengajar serta memberikan kemampuan mahasiswa serta dosen untuk mengupgrade kemampuannya. Beberapa laboratorium tersebut adalah Laboratorium Struktur dan Bahan Bangunan, Laboratorium Mekanika Tanah, Lab Hidro, Laboratorium Manajemen Transportasi, Laboratorium Pemetaan, dan Laboratorium Komputer. Ketika melaksanakan pendidikan di program studi teknik sipil, maka para mahasiswa mendapatkan peluang-peluang yang bisa dikerjakan, di antara lain adalah memiliki peluang untuk melaksanakan kredit transfer di beberapa universitas baik di dalam negeri maupun luar negeri. Beberapa kerjasama internasional yang telah dijalin yaitu di antaranya dengan University Teknologi Unara Malaysia, Yuntech Technology Science and University Taiwan, Chung-Ang University Korea, dan Central Supelec Prancis. Dari Prodi Teknik Sipil adalah lulusan Prodi Teknik Sipil, beberapa mendapatkan beasiswa untuk melanjutkan S2 di dalam negeri maupun di luar negeri.
Program Teknik Sipil Universitas Negeri Semarang, kita diajarkan bagaimana cara merancang, membangun, dan merawat secara berkala bangunan-bangunan yang telah dirancang dan dibangun. Ini agar pembangunan dapat realisasi dengan baik dan tanpa ada kekurangan apa.
Halo, Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan, nama saya Irfan Abidin. Saya alumni Universitas Negeri Semarang. Saya angkatan tahun 2014. Di sini saya bekerja sebagai konsultan supervisi yang mengawasi pekerjaan PT Waskita Karya. Dan saya bekerja di PT Delta Global Struktur. Teknik sipil siap sukses, harus sukses. Terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. Perkenalkan, nama saya Hamzah. Saya alumni dari Teknik Sipil UNES, Universitas Negeri Semarang. Saya masuk di UNES tahun 2012, mengambil jurusan Teknik Sipil. Setelah saya menyelesaikan studi di Universitas Negeri Semarang, saya melanjutkan pekerjaan di salah satu international consulting firm, yaitu di PLTU Tanjung Jati B di Jepara. Tidak hanya itu, UNES juga memberikan kesempatan saya untuk bisa bersekolah di luar negeri, salah satunya yaitu berada di sini di National Yunlin University of Science and Technology, di Yuntech.
The next event, our main event for agenda today, will be guided by the moderator of the first session. To Dr. Rizky Fitri Naryanto, the time is yours.
Okay, thank you, MC. Good morning, everybody, and welcome to 11 Engineering International Conference 2022. To the Honorable keynote speaker of 11 Engineering International Conference 2022, especially in the first session, Professor Dr. Ismail Saad and Professor Dr. Nur Aswadi Cesidik. To the Honorable Rector of Universitas Negeri Semarang, Professor Dr. Fatur Rahman. To the respected Dean of Engineering Faculty, Universitas Negeri Semarang, Professor Dr. Nur Kudus. To the respected our speaker, organizing chairs, and also distinguished participant. Ladies and gentlemen, I am Dr. Rizky Fitri Naryanto. It gives me great pleasure to the moderator for the 11th of Engineering International Conference 2022. With the topic, Applied Green Technology for Environment Conservation through Continuous Engineering Innovation. Before we get started, I would like to offer a few items so that you know how to participate in today's event. First, you have to mute your microphone during the keynote presentation. Second, please turn on your video and adjust the speaker volume. Our keynote speaker will deliver the material and you will have the opportunity to submit the question to today's presenter by raise your hand and giving the question directly to the keynote speaker. Now, I would like to introduce our first keynote speaker. He is Professor Dr. Ismail Saad. Hello, good morning, Professor Dr. Ismail Saad. Are you here? Are you there? Okay. First of time, I would like to read his short CV.
Sorry. Can you hear me?
Yeah. Okay, I can hear you, Professor Ismail.
Thank you.
Okay. Professor Dr. Ismail Saad is an associate professor at the Electrical and Electronic Engineering Program, Faculty of Engineering, University Malaysia Sabah, UMS. He received his PhD from University Technology Malaysia in 2009. He was awarded the Chancellor and Best Student Awards during the convocation ceremony. His Bachelor and MS Master of Science degree is from University Putra Malaysia and also from University of Southampton. His research area is cover micro and nano electronic device and material, digital integrated circuit system design, and nanofiber membrane for energy application. He is a member of the Board of Engineer Malaysia or BEM, Institute of Engineer Malaysia or IEM, and a senior member of IEEE. Wow. He was elected as the first chair of the IEEE Sabah subsection in 2017. He has won various awards in Malaysia Technology Expo, BU Innovation, and UMS Research and Innovation competition. He has secured over 1 million research grants with numerous dedicated collaborative research partners. He has published more than 100 Scopus Index papers. He is currently the Dean in Faculty of Engineering, University Malaysia Sabah. Okay, I think this is very great CV. Yeah? Okay, today Professor Dr. Ismail Saad will deliver his presentation about sustainable modeling and simulation of nanoelectronic device miniaturization. Okay, we thought further let's welcome Professor Dr. Ismail Saad. Dr. Ismail Saad, time is yours.
Okay, thank you very much. The Rizky, I think.
Yeah.
First of all, maybe can I share my screen?
Okay.
Okay, how I want to share? Okay, how I can share my Outlook? Cannot able to share my screen. Can
not yet. Not yet.
yeah. I think it been set only host can.
Okay.
Yeah.
Okay, you can share now.
Okay, hold on. We'll try first. Okay. Some problem, maybe. I don't know why. Okay, why I cannot share? I can try to share. I got some problem here. Yeah, I cannot seems to share my desktop.
Okay.
I try because I cannot see.
Excuse me, Dr. Ismail.
Yes, yes, please.
You could send your presentation to Dr. Faisal so that we will help you to present your material. Thank you.
Okay, okay. Hold on, maybe there's some issue on my privacy. Hold on, Okay, I try to share now. Hold on,
Okay.
Okay, now?
Yeah. Now we
Okay.
can see your PPT.
Okay. Thank you very much, Mr. Chairman. I hope that everybody can see my slide. I'm going to go for the slide presentation. Okay. Now, everybody can see my slide, or it's a different slide? Is it full space or which one? I have to swap. I think this one is better.
Yes, yes, yeah. This is
one
better,
is okay.
better, Professor.
Okay. All right. Sorry, because it's I'm using two screen. Okay. Hold on. Let me. Okay. Let me check first, because I cannot see the. Okay. So, Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam.
First of all, thank you very much for the brief introduction. And then also I want to put my thanks to the chairman of the EIC 2022, I think Prof. Faisal, who inviting me to become one of the keynote speaker for today. So I hope that I can deliver, I can share my topic for today, which is sustainable modeling and simulation of nano-electronic device miniaturization. Again, I have been have a good time when I'm visiting UNES University together with UNDIP, I think back in 2017 or 16, and I have a pleasure to meet the Professor Kudus, which is the the dean of the Faculty of Engineering, University of UNES. Okay. All right. So allow me for giving 2 or 3 minutes to give some sort of introduction about University Malaysia Sabah. We are located in the Borneo Island of Malaysia, near to Sarawak. So for those of you who have come to Malaysia, please come also to Kota Kinabalu. So a brief introduction about the University Malaysia Sabah. We established in 24 November 1994. So the university is almost 28 years, coming to 30 years. So it's still baby, and then we are trying to develop our university. And currently we have around 12 faculties, and engineering faculty is one of it. And we have 1 academy, 4 research institute, and we have around, in total, we have 138 academic program, which is comprised of 24 PhD, 33 master program, and around 69 of a bachelor degree program and 2 diploma and 3 pre-university program. We have 3 campus located. The main campus located in Kota Kinabalu, and we have also in Sandakan and also in Labuan, located quite far also from Kota Kinabalu. And then University Malaysia Sabah is the 9th public university in Malaysia. So number 9 is quite synonym with the university, where we have land area around of 999 acre. And currently we have around total number of students around 17,500. That includes the undergraduate, postgraduate, diploma, and also foundation. And we have around 2,542 the postgraduate. And the academic staff, we have around 1,083 with almost 60%, 57% with PhD. And we have around total staff of 1,912. And with the alumni that already working outside all over the world, around 75,200. Just to share with you, I think there's some lagging. This is our nice campus. We really anticipate maybe some of you can come to Kota Kinabalu, Sabah, and then also come to visit our campus. The first picture there is our chancellery. We have chancellery hall, and then we have our own jetty, and we have our own beach, so you can have your own beach. And then we show there we are 12 faculties. So we are one of the faculties in the University Malaysia Sabah. And I think I think UMS is a quite attractive location for tourism to come to visit us. And then hold on, okay, this is our building. So if you are coming in through the main gate, our building is located on your right-hand side. And then we are I think the second biggest building in University Malaysia Sabah. So a bit brief introduction about our Faculty of Engineering, University Malaysia Sabah. We are 2 years younger from University of Malaysia Sabah, because we established in 1996. So we are 26 years, and previously we are known as a School of Engineering and Information Technology. But now since 2014, we are on our own with Faculty of Engineering, and then we have 18 programs. 18 programs that include 6 undergraduate program, 11 postgraduate program, and 1 diploma program that covers almost the same with the Faculty of Engineering UNES. We have civil engineering, electrical, electronics, chemistry, mechanical, electronic, computer, and the new one, I think we have oil and gas engineering. And then we have PhD and master by research and master and diploma in oil and gas. And our strength of academic staff, we have around 108 academic staff with 78% with PhD. And we have around 224 postgraduate students, and around 9% from international. And then we have around 1,164 undergraduate students. And then all the program was accredited by the ESC, Engineering Accreditation Council Board member, where we registered with Washington of Accord. And then we have around 55 administrative and support staff. And in total today, we have around 5,528 alumni. I hope that this can spark your all the audience to visit us in Land Below the Wind in Kota Kinabalu, Sabah, inshallah in due time. Okay, so just sharing about Industri Malaysia Sabah. So I go to the main agenda for my sharing today. I think about the nanoelectronics roadmap. I think we start by in 1906, where the Lee De Forest invented the vacuum tube. That is the starting point of nanoelectronics. And then using the vacuum tube in 1946, I think this is the first computer in the world that use vacuum tube, but we call it as ENIAC. And it's come with the big size, huge power, but it's very short time filament, and it need many people to operate this first computer in the world that use vacuum tube. Going down the years, in 1928, Lilienfeld has patented the device that will work like a MOSFET, but during that time, they don't call it as a MOSFET, but they call it as a pattern control electric current. Okay, but it's not really good because during that time the integration or interface property between the semiconductor and gate insulator was really bad, and then it's not giving a very good performance. Nevertheless, in 1947, I think the first transistor in the world has been invented by William Shockley and the friend J. Baden and Bratton. I think that's if you study the solid state electronics, you will see this very famous picture. But the first one they are invented is the bipolar transistor, and that used the germanium rather than the silicon. And it's a first solid state device that based on amplification of electron, emitter base, and collector. And then okay, continue in the line. In 1960, I think the first model of MOSFET been invented by the Dikang and M. Atala, which is because of they can resolve the issue of silicon and silicon oxide interface and working very nicely. And it is the first MOSFET that been invented that been used until today. And from that point of moment, in 1970-71, I think the first generation of large-scale integrated microprocessor has been invented. Then they have to do a lot of things. They do DRAM, microprocessor unit, and Intel 4004. And nowadays, I think 2011, we have 128 gigabyte SD card. I think this is also all because nowadays we even have 1 tera gig of SD card. If you can see that this very small, just a bit of comparison, you can see this 128 gigabyte is just sorry. Okay. Okay, it's just 22.4 cm times 3.2 cm with the weight of 2 grams. And if you compare with the population of world is around 6 billion. Our brain cell, we have around 10 to 100 billion, and the star in galaxy is 100 billion. But if we convert 128 gigabyte, I think you times it by 8 bit, you can have around 1.024 terabit. And this 1 tera is almost 1 trillion, is more than the star in the galaxy. This is only 128 gigabyte. What more for the 1 tera? So I think with the all technology and the fabrication technology now, we can have a lot more in a very small and very small size of transistor. So the challenge is now how we want to go beyond 2020, beyond 2022. So we have to see on downsizing, the miniaturization, we have to reduce the capacitance, think the capacitance is one of the making the lagging of the MOSFET, because it's reducing the switching time of MOSFET. And then how to increase number of transistor. And because when you have a number of transistor, we can have a lot of parallel processing, increase the circuit operation speed. So miniaturization will continue in the driving force for circuit evaluation, and from micro to nano device, VLSI, and then we have to go the transistor channel length are reduced by a factor of 2 every 3 years. This according to the Moore's law, while the chip density increased by a factor of 4. So what next need to be done? So this is a challenge now. So we want to make a smaller device, because with the smaller device, we can have faster performance, bit integration, and portable easy storage. And how small can be a small? Okay, nowadays we have around 45 nanometer for the Intel Core 2 Duo. And now, even in 2011, we have 32 nanometer Intel Core i5, Sandy Bridge. And even now, i7, i9 also, they're using 22 nanometer in 2012. So this is a lot of, they're going to very small and device miniaturization. However, do we need to go to that small? That's the question. So I think some of the things that even the old technology, maybe 45 or 60 nanometer, can be used for different purpose. We can use for analog, passive, high voltage power sensor actuator, which is no need to become no need to become smaller, but they have better function. So this is the way that we go beyond CMOS, and we have to go more on sustainable design of our circuit. So to go to the nano electronics, we have a miniaturization challenge. We have a lot of challenge because the demand of the user, everything they want to be smaller. Just recently, iPhone released iPhone 14 with a very biggest and very good performance chips, dual core. So all these things need to have miniaturization. So one of the things I can highlight here, I think can highlight eight of the challenge. When we go for the miniaturization, we have to reduce the carrier mobility because it's in high electric field, it's a very significant mobility in nano device, and also the high sub-threshold slope, because the high sub-threshold slope will limit the on-off of the device, because we need we don't want leakage current over there. The limit now is 60 milliwatt per decade, but with the current technology device, I will share with you after this how we can overcome this challenge. And also the heating, because of the hot electron effect in high field area, increase the power consumption due to the number of transistors being put into a very small area. So the power consumption is increased. Leakage current is interrelated with the sub-threshold slope. So we have to have a lot of leakage current from the gate, substrate, and source drain leakage current. Hot carrier effect due to the drift, high field saturation current, lower switching speed. Okay, so to on and off, and higher supply voltage. So all this need to be overcome before we can go for our miniaturization. Okay, this is just a picture of the MOSFET, PFET and NFET, and then just to show you the LED dielectric that become very thin now, 1 to 2 nanometer, and then the channel doping also. You need to be retrograde, super hollow, to counter the threshold voltage rod off, and It's a lagging issue over there. I don't know why my slide. Okay. All right, so this is a issue that we've been, then how you want to overcome this sustainable approach. So one of the way in order for us to do a research in this area, in the CMOS nano regime, one of the, so that we can sustainable in order to overcome all the effects. I think I can highlight here four approach or method that we can use. The first one is we can use a different material set with better performance than silicon. Nowadays they use carbon nanotube and so on, but however, some of the material still is under testing, and also some of material is not really suitable for your application. So you have to carefully check whether either this material is suitable for your device or not. Number two is we look at the structure or the new structure of device or nano device structure. So we'll say to you how we have dealing with few structure that we have already simulated, and then if become a very promising device for new era. And then another thing is we have to do transport mechanism. This is a very transport mechanism for current conduction. We have to explore how is the electron behave in a very small channel. So we have to understand from mathematical point of view, from the modeling type, how is the transport of the electron from source to drain in a very small device. And other thing is we have to diversify the device application, not only for maybe not only for a very small one, but we can use for the high voltage power and so on. That one we can do that. Okay, so in this sharing, I'm going to share with you the computational modeling and simulation towards sustainable nanoelectronic miniaturization. We'll share with you the work that been done in our group here about the ballistic quantum modeling that to cater for carrier transport in nano device. Then we're going to share with you also the ticket simulation, technology computer aided design simulation that you use using the Athena and Atlas device structure for BASIMOS for nano regime. And also we share to you how we implement from the modeling simulation, and then we look the application of the device into biosensor. For the biosensor, we call it as a BASIMOS. And then if I can find, I can share with you the nanofiber for energy, but I will share with you also some approach of the how we can use artificial intelligence for a nano device design. So this is a new, not new actually, but it's a very emerging area that how they can do the performance of device using the AI technique. Okay, so go into the first topic, the computational modeling of ballistic quantum transport in nano device. I think from the classical to the quantum, when you do is in classical, we use a lot of diffusive quasi-ballistic, but in quantum actually is how the electron travel is like a ballistic. So we have to know, we have to understand this phenomenon, and then we have to relate it into our device MOSFET. So what is the ballistic transport, ballistic carrier transport? If you compare with the long channel MOSFET and short channel MOSFET, long channel, they are based on the drift diffusion transport. But in the ballistic transport, there's no scattering. Okay, so it happens when the channel length of the device becomes smaller, than the mean free path of the carrier. So very little scattering within the shell, and then is traveling like a ballistic. So that's why when we miniaturize, the device become good in the performance. Okay, but we have to understand this phenomenon. So we have referring to the Naturi ballistic transport model. They use compactly MOSFET using the elementary parameter without depending on the carrier mobility. We don't have any carrier mobility over there. So you have to think of as the device as elementary parameter. So with modeling, and then we have, this is in 1994. And also we base our research on Landstrom ballistic transport. They also say that the carrier distribution consists of two thermal equilibrium, one injected from the source and another one from the drain. So this is also one of the how the Landstrom modeling the ballistic effect. However, in our research, we started with the derivation of low dimensional energy spectrum and carrier statistic for quasi 3, 2, and 1 dimensional. So we have all the elemental parameter based on the Naturi also, and then we have all this equation for the 3D 2 and 1 system. So we have plotted what we call as the quantum effect in non-degenerate regime that is essential for the nanoscale transistor modeling. So degenerate on degenerate because of the what we call as 3D or 1D or 2D or 1D carrier statistic. Okay, so that's our finding. And then the next one, sorry, what we call the next one? Okay, we derive the ballistic velocity in low dimensional nanostructure. And then we say that in high current or high field current, so the velocity of the, sorry, why this is happening to me? It become, let me, okay, so take some time. Why? Oops. Okay, so we developed the physics-based model based on this velocity saturation velocity in low dimensional structure for the 3D, 1D, and 1D. And then we looked at the carrier statistic, all looks very fine in all the 3-dimensional, but we go to the non-degenerate for different doping concentration. Okay, and then we continue our modeling to derive the IV curve, IV characteristic of nanoscale transistor with the quantum effect and ballistic transport. We model that with the what we call as thickness of oxide. Okay, and then with the quantum effect, we put it there, and then we verify our model with the data that we have from the Intel, and then finally I don't know what happened. We have the drain current equation. Okay, and then we have the velocity, and then we have the ID set. Then now we have the IV curve, drain current versus the drain voltage, and then the green one, this one showing the data that we have from the Intel. Oh, okay, and then it shows that it very almost less than 5%, almost agree to our model for the ballistic transport for the nanoscale transistor. And we have published this paper in 2007 in the Applied Physics letter. It take some time to do this because we have a very we call this a very harsh review of comment in order to publish this paper. Okay, so the next one, I need to go fast because I think already using a lot of the time. Ticket simulation for the vertical stack impact understand MOSFET. So we use the ticket simulation. Maybe I can skip this one because this is the Silvaco ticket environment. And then this is also how they can model it through the mobility impact analysis. And just show to you the result, the device that we have. And then we want to overcome actually the 60 milliwatt per decade. So we dope that, and then finally we can have the transfer characteristic, and then we have around 9.85 milliwatt per decade, obtained at threshold voltage 1.1 volt with drain voltage 1.75 volt. So this is the lowest threshold voltage that we have for this BESIMOS. Okay, so and then this is the output characteristic. Is using looks like never saturate. That's the limit of the planar IMOS. And then we also do some strength characteristic, and we verify the number of germanium content from 10 to 50%, and then we can see that 30% giving us an optimum value. So we make another study where we put two single silicon germanium layer into the device, and then double channel BESIMOS, and we do have the transfer characteristic for both of them. Then we can see that a very good what we call as threshold transfer characteristic for this device with the germanium of 30%. So that's the optimized value from the simulation. Then we have to compare. Then we have around 9.85 and 10.98 milliwatt for decade. So we have compared this one, and then we have shows that the single layer silicon germanium shows a very good performance. However, you can also go for the double channel. They have some trade-off over there in order to have a very good performance. Okay, and then we have another one where we put dielectric pocket in the BESIMOS there. Okay, and then the benefit is that sorry, my why is like that? Oops. Okay, this is the then this benefit of dielectric pocket because it's as a function of reduced charge sharing, and then lead leakage current due to the PB effect, and then also diffusion into body. So also we have make some study on how the parasitic bipolar transistor effect has been surprised using this PBT, using this structure of device. Sometimes it doesn't come out. Okay, never mind. And this is the transfer characteristic that we have. So they go from CMOS mode into impact ionization mode and bipolar mode. And also this one, the transfer characteristic and the output characteristic of the BESIMOS. And then that's it. So we finalize, we continue our research. We pick one of the device to apply into the biosensor BESIMOS for biosensor application, because we want to see its effects in linearity, sensitivity, selectivity, and response time. So after make comparison, we see that the single channel, double channel, and BESIMOS with the dielectric pocket, we compare it, and then we choose the double channel BESIMOS as a to apply as a biosensor, and then we using the equivalent circuit. This is BESIMOS, and then we have a characteristic over there, and then we show that it's a very suitable become to use as a biosensor application. We verify with the the data that we have from I think Ramli in 2014. Okay, so that's the third one on to sharing, and then coming into the end of my sharing, how we can use the AI technique for nanoelectronics. So there's a lot of going on now. They call us CNT FET simulation using artificial neural network. In 2019, they're using the artificial neural network. So this is work by Tamersit, and is giving a very promising output characteristic. And also this is a nanoscale double gate multi-objective genetic algorithm by Bandip and the gang. And then they also shows a very promising, but I think they compare some of the signal with the numerical simulation. And then also this one is from particle swaps swarm optimization using the genetic algorithm for the gallium nitride device, and also the using ANFIS for the nanoscale simulation. So going to the last part of my presentation, I think I have using a lot of time. So as a conclusion, I think I want to share with you the computational modeling of ballistic quantum transfer funding shows as a sustainable approach of nanoelectronics, meaning to say we can use the modeling using the MATLAB, or we can start from the mathematical modeling just to see many effects. One of the effects is a ballistic quantum effect, which is still undergoing until today. To understand it using the computational modeling. Number two, I think the ticket simulation will be utilized for the Vesimos, and we can say that the ticket is one of another option. However, I think for the ticket, we have to spend a lot of money for the license, and this is quite sometime we can use our grant money or so on. And then we shows that we can use the Vesimos application in the biosensor, so that we can use for the biosensor. And currently, I think we have managed to secure a grant for using this device for the what we call as EMG, EMG muscle signal for the biomedic application. So I also share with you some few example of AI approach for nanoelectronic computational for the future direction of sustainable device monitoring. So with that, I think with the time, I'm more around 3 minutes. Sorry for that. And I want to take this opportunity to acknowledge my postgraduate student, Zuhir Bunseng, you and the research member, Professor Dr. Nurmin, Dr. Bablu, Dr. Khairul, Dr. Afisha, and also we want to acknowledge the contribution of grant that we have from the MOSTI, Minister of Science, Technology, Innovation of Malaysia, the ASEAN Fund, and also from the Ministry of Higher Education of Malaysia, we have a grant, and also for to UMS that providing excellent research environment to complete the work, and also for the ESC committee and the chair of the ESC that giving me the opportunity to share this this talk to all the audience. So with that, thank you very much. Again, back to you. Maybe I should end this this presentation. Okay. All right. Okay. So back to you, Prof. Rizky.
Okay, thank you, Professor Ismail Saad. I think it's very, very interesting presentation.
Yeah, sorry.
I hope someday I can join in UMS, Universitas Malaysia Sabah, maybe for postdoctoral. Okay. Okay, thank you, Professor Ismail Saad.
Thank you. Thank you.
Yeah, maybe for the audience, please, if you have some question, you can directly raise your hand in Zoom panel and say what is your question, please. Okay. Good morning, Mas Muhammad Irfan.
Good morning,
Your question, you can
Yes.
directly say with the Professor Saad, please.
Before it, should I introduce myself or not? No?
Thank you.
Okay. Professor Ismail Saad. As you has explained, now the technology of processor is more smaller. We know that the newest Intel processor 12 gen or older like it is have the 10 nanometer technology, and then for EMT 700 series, it is have the 5 nanometer technology now. You have explained that more smaller the nanotechnology MOSFET fabrication, it is more higher performance. For the smaller MOSFET fabrication, it is have the impact on the CPU performance, like the increase the core and then thread, and then the performance of single core and then performance of single thread. So, and then the second question is, what happened if in the future the fabrication of processor it's more smaller than 1 nanometer in the future? It is maybe possible in the future, sir. Okay, I have you have understand my question, sir, because my English is not good for speaking. Thank you, sir.
Okay, thank you, Irfan. I think a very good question from you. I think you have been listening to my sharing talk quite focused. Okay,
Yes, sir,
I think
because I very interested with computer technology, like the processor, the RAM, and the GPU. I'm very interested with that. So,
okay.
yes,
Okay, that's why you have can follow. Very good. Okay, thank you for the share. I think I can hear for the second question, but the first one I cannot get it very clearly. But let me answer the second question, which is I think the most the one that boggling your mind, because the question, I think, if I can repeat now, can we go, how we want to fabricate if we go less than 1 nanometer? That's the challenge, actually. So we have to, can we do it? That's a big question, a very simple question. Can we do it? Can we fabricate a device that less than 1 nanometer? That's the question. I think there's to answer your question, we have to look back on our history, because when we started in 1906, we don't have any transistor in our hand. Okay, so we start with the vacuum tube, and until today, we have a very good technology. And I know that with the IR 4.0 and a lot of researchers around the world, they are really going towards that. Okay, but I think there's a limit for that. If you want to go more than 1 nanometer, I think you cannot go based on the silicon as a material. You have to go for the compound semiconductor. So that technology will coming soon. For example, carbon nanotube, gallium nitride, all the compound semiconductor. But the question is, are we really need to go to that smaller? Are we really need that? That is another question, because I think with the technology that we have currently, that already matured, 45 nanometer, 50 nanometer, they're very matured. We can do a lot of application on that. Okay, and then it can contribute to the technology. even better. Okay, so I think while we are working, okay, there's some group, some researcher around the world is working on the miniaturization of the device, goes up to beyond the 1 nanometer, but there's some group also, they diversify the application of this device. So I cannot give you yes or no answer for that because the current research is still going on. Because now they also have research on quantum computer. They try to do that. We did all technology is possible for us to have a webinar like today. We are very far away, but we can still doing it. We don't know down the road, 10 years down the road. All these things become available to us because of the transistor invention, because of the electronics, because of the computer. If we don't have it, it's almost impossible for us to have this webinar or this kind of online technology, online conference. I hope I can answer that, the second question, but I cannot remember the first question. I think more or less, I think it's the same, Irfan. Sorry, I cannot hear. I think Dr. Rizky, I cannot.
Maybe you can unmute Mas Irfan. Okay. Is this satisfied for your question? The answer from Professor Said?
Yes. For the first question is how the smaller fabrication semiconductor is impact to computer performance, like the increase the core and chip of processor.
Yeah. I think
why it is can impact.
Yeah. The impact of the smaller, I think if you have a very small transistor, you can have a lot of things. You cannot imagine when I'm studying just now, during my time in 1994, we can have a tablet. We can use your Samsung tablet or iPhone tablet. But nowadays you can have it. You can have everything in your hand. So the impact is quite tremendous. All this thing has been made possible because of the transistor technology. If you don't have the transistor technology, you cannot do this. Okay, so that's why the impact is quite huge. And it's a very important that we have to make R&D research on this matter so that the computer will become more functioning. But you can see that now with the old technology, i5, i7, i9 is quite expensive now because of the newest technology. But it comes with the price It comes with the price. But later on, when it's obsolete already, we say obsolete, but certain people can use that. So I think it's a huge impact to the computer revolution. Okay, I hope that I can answer your question.
Okay, I think enough. Maybe you can continue the discussion after this conference. Okay, for the next session, next question, maybe with your reaction. Okay. Mr. Mira, please, you can directly say your answer. So your question.
Okay, thank you very much, Mr. Moderator. Good morning, Dr. Ismail.
Morning, Assalamualaikum.
Waalaikumsalam. My name is Mira Kartika Dalimayanti from Polytechnic Negeri Jakarta. My background is computer science, but I'm very interested on this discussion. What do you think about this fabrication of this nanoelectronic? Is it possible to create by your laboratory or your university? Because maybe some participants in here will be interested to conduct collaboration to develop this technology. Thank you.
Okay, thank you for asking this question. Actually, it's quite challenging in the fabrication because in Malaysia also, I think we don't have many clean room facility. Okay, even in UMS also we don't have. So what we do actually in my laboratory, normally I send my sample for publication into my research partner. We have in UNIMAP in Perlis, we have in UKM, in University Kebangsaan Malaysia. If you remember, Prof. Burhanuddin, now retired. So we continue our fabrication over there. And also we have smaller industry Malaya, but we don't have any complete so-called clean room, okay, in Malaysia. I think there's one nanotechnology, Persatuan Nanotechnology in Malaysia. They're trying to have a clean room, but still, I think due to the pandemic, I think the project has been halt. But nevertheless, don't make these things stop you. Because we have a research partner all over the world. Currently, I have a research partner from Seoul National University, and then we can use the facility over there. Of course, from our grant money, then we can pay the fabrication over there. We can send our design. They can do for us. But you have to have a very good linkage with them. We have a very good linkage with Seoul National University. And also in Germany, also you can send. But all these things need money. So that's why, while waiting for the device to be fabricated, so that's why I propose what I call as a more sustainable approach, which is we use the whatever we have.
Yes.
Okay. The very basic that we have is we can have a MATLAB program.
Okay.
MATLAB. Then you can do a modeling immediately to derive the drain equation and so on, and then to see the effect in nanoscale. This one, you can do it, and then you can just asking maybe some collaboration with industry. For example, in Malaysia, Intel, we have a very good relationship with Intel to get the data to publish it in journal. Because when you're doing modeling, you cannot really just modeling, but you have to compare your analysis with the real fabrication data. So we have a data that we get from the Intel, then we compare it, and then we publish it in the journal. So this is a kind of things that we have it. Yes, it's our dream to have our own clean room, but
that's right.
I think it's quite using a lot of money, not only to have the clean room facility, but to maintain it is using a lot of money as well. So thank you. I'm also very concerned of this one, but I hope that this doesn't stop you, because it doesn't stop. Because if you're passionate on this matter, then we can do a lot. Because with this borderless, we can travel, we can do online and so on. So we have never this one will stop you to do research. Thank you for the question.
Thank you very much for the question, the answer. Thank you, Mr. Moderator.
Okay, thank you, Bu Mira. Maybe another audience will have some question, can directly. Okay, I have some question. One question from Pak Bambang Triatma, Professor Saad.
Yeah.
Discussing about nanotechnology, we all have a concern to the danger of WIPO patent 2020 090909 describing about cryptocurrency system using body activity data launched by Microsoft. This technology need the role of graphene oxide to build a receive transmitter that working inside the human body in our blood. This technology has made US a hybrid human component of flesh and machine. So we are almost aware the set of the nanotechnology. So how about your opinion, Prof. Saad? I'm sorry, I'm not from electrical. I'm maybe some miss.
Okay, thank you for the question. I think your question is more related on the safety of the nanotechnology application, right? Because I think nowadays also there's a lot of application using the nanotechnology. One of it is what you mentioned. Another one is I think they are also developing that you can have a capsule that inserted into your body, so that due time they will release the medicine without need to take it from your mouth. So you implant it into your body. But I think the question is back into the human, your rights as a human, either you want it or not. I always pose this question to my student. But if you ask to the very healthy person, they will say no. They will say no. Immediately they will say no, because it's my right. It's a human right. You cannot put anything, because as Islam also, when we die, we have to remove before we go to the dikumikan and so on. So it's some of the religion also taking into account. But if the developed country for US and so on, and if you are really sick and you need that technology, I think you have to consider that very carefully. Because we don't know, in the near future, maybe we don't need to take our medicine from our mouth. You just implant it into our skin and they will release the medicine according to the need of your body. Okay, so and then the design also, I think, the researcher all over the world, in fact, they are collaborating with the medical expertise, and they really consider this thing. I hope that this technology, maybe in near future, we may or may need it. Up to today, we cannot answer that, but who knows? Who knows? Sometimes we don't know that. As you can see, previously about this e-learning and so on, they say, we don't need the e-learning. Why would I need the e-learning? I just like to do face-to-face. See, some people say like that, can, especially in engineering. But nowadays, we cannot run away from it. So I cannot give you a very direct answer on that. But I think if go back to the human rights of our people, you can have an option to opt or not to opt the technology. But the technology is carried on. You cannot stop it. They are really doing it very much invention and innovation in this matter. Thank you. I think I can answer. That's my personal opinion.
Okay, thank you very much, Professor Saad.
Thank you.
I think your presentation is very, very interesting. So, so many audience want to ask.
Yes, thank you.
But unfortunately, I have to stop this session and continue to the second keynote speaker.
Thank you.
Okay.
Thank you.
But please don't leave this Zoom, Professor Saad, because we have to continue.
Yeah. I'm glad to listen to the second keynote speaker.
Okay.
Also.
Okay.
Thank you very much. Thank you.
Yes, you're welcome.
Thank you.
Okay. Now we will continue for the second presentation. I will introduce our second keynote speaker. He is Professor Dr. Nur Aswadi, CSIDIC. Professor Aswadi, are you here? Can you hear me?
Yes, I can hear you.
Okay. Thank you very much, Prof. Nur Aswadi. Good morning, Professor Nur Aswadi. Professor Nur Aswadi, CSIDIC is a professor at University Technology Malaysia and also Malaysia Japan International Institute of Technology, or MGIIT. His expertise is in computational or experimental fluid mechanics, nanofluid, convective heat transfer, and numerical methods. His academic qualifications are in the Bachelor Science in Mechanical Engineering and Material Science from Kumamoto University, Japan. Master Science is in Thermal Power and Fluid Engineering, University of Manchester Institute of Science and Technology, UK, United Kingdom. PhD, Philosophy of Doctor, is from Mechanical Engineering in Keio University, Japan. Genki desu ka, Sensei?
Hi, Genki desu.
Hi, I'm from Kanazawa, from the university. Okay, he has so many career achievement in so many, but I'm sorry, I just only read a few of the career achievement. October 2008, he is to be a coordinator of postgraduate program, Mechanical Engineering, Faculty of Mechanical Engineering, UTM. In February 2010, he to be head of Department of Postgraduate Studies, FKM UTM Skudai. And February 2017, He is to be coordinator of postgraduate program for mechanical precision engineering MGIIT UTM Kuala Lumpur. And now on August 2018 until now, he is to be Deputy of Dean, Academic and Student Development, MGIIT UTM Kuala Lumpur. For the awards and honors received, he is to be a Malaysia Research Start Awards for Young Researchers in National 2018, and also Top Research Scientist Malaysia in 2020. Wow. Okay, in administrative appointment, he is to be Deputy of Dean, Academic and Student Development. Yeah. And he have so many professional membership. First, as Executive Engineer R&D Department Matsushita Audio Video Johor. Second is a member of International Association of Computer Science and Information Technology, IEEE member, American Chemical Society, and the last is the member of World Academy of Science, Engineering and Technology. He also have so many patents in wing ground craft and micro channel heatsink, and also journal management system. For the publication, Professor Aswadi have 346 article indexes in Scopus with 43 H index. Wow. And the citation is 5,883 citation in Scopus. Yeah. We have original book with 5 book and also 12 book chapter published. Journal Editor-in-Chief. He is to be Editor-in-Chief in Journal of Advanced Research in Applied Mechanics and Editor-in-Chief Journal of Advanced Research in Fluid Mechanics and Thermal Science in 2014 until now with the Scopus Index. Third is Editor-in-Chief Journal of Advanced Research in Material Science, 2014 until now, and Editor-in-Chief Journal of Advanced Review on Scientific Research, 2014 until present. Okay, Professor Dr. Nur Aswadi, CSIDIC, will explain about laminar force, convection, cooling, and hybrid microchannel heatsinks with secondary channel for electronic device with sustainable cooling solution. Welcome, Professor Dr. Aswadi. Now time is yours, please.
Okay. Thank you very much. Thank you very much, Prof. Dr. Rizky, for very nice introduction of me. Thank you. And before I start, I would like to thanks to the organizer of EIC 2022 for inviting me to give a keynote speech for the conference. And also I would like to thanks to everyone for participating in this conference. All right, so thank you very much again. Assalamualaikum, very good morning, and ohayo gozaimasu. All right, okay, so I am from University Technology Malaysia, under the Faculty of Malaysia Japan International Institute of Technology, or MJIIT. MJIIT is located in Kuala Lumpur, even though our main campus is located in Johor, but the Faculty of MJIIT is located in Kuala Lumpur. Okay, and we are, MJIIT is one of the 7 faculty under UTM. All right, okay, so I will be presenting together with my partner, Dr. Wan Muhammad Arif. Dr. Wan Muhammad Arif was my PhD student, and I can say he is the best PhD student so far, graduated under my supervision. And okay, he will share the slide and continue the presentation, because I'm training him because yeah, he is one of the best students under the faculty. So can you let Mr. or Dr. Arif to share the slide? All right, okay, so this is Dr. Wan Muhammad Arif. So we are going to present actually his PhD thesis. Okay, he got excellent remark for his PhD presentation and also PhD thesis. And I bring the thesis here, the thesis presentation here, so that the world can know what we are doing. And the title will be Laminar Force Convection Cooling in Hybrid Microchannel Heat Sink with a secondary channel for electronic device with sustainable cooling solution. So to proceed with the presentation, so I'm very honored to invite Dr. Wan Muhammad Arif to, on behalf of me, to present the content of the presentation. So Dr. Arif, can you proceed?
Okay, Assalamualaikum and very good morning. Is it my voice clear?
Yes, very clear.
Okay,
It's good.
okay.
We can clearly.
Okay, today I would like to present about our research. So I cannot next. Okay, this is a presentation outline for today's presentation. We will start with the introduction and we finish with the conclusion. Okay, rapid development in electronic industry produce many advanced technology. Computer is one of the technology that we frequently use in daily life, especially during working hours. As we can see here, even the size in 1917, even the size of the computer is bigger than current computer, but the number of transistors built in the microchip is only around 2,300 only. However, in 2022, the number of transistors built in the microchip is around 140 billion. May you imagine the number of transistors in the future? Actually, what I want to try to say here is that even the size of our device becomes smaller and more compact, but the number of transistors is keep increase. Based on the Moore's law that used by Intel for transistor count observation, they state that the number of transistors doubling at every 2 years. Why all this happen? This is because of the customer need. Growing demand for reducing weight and volume for a new device has led to the current development of technology. However, the new generation microchip that consists of billion number of transistors has increased the heat dissipation in the electronic device. Actually, the conventional methods such as air cooling technique inadequate to remove the such efflux. There are several microcooling methods has been proposed by the previous researcher, and microchannel heat sink appear as a promising method that can provide high heat transfer rate with minimal thermal resistance, and it easy in manufacturing process. However, the problem is the conventional design such as the straight channel design has limit the true potential of the microchannel heat sink. As we can see here in this straight channel design, in the fluid region, there are two distinct temperatures, cold and hot water. Means that only water at the side wall involved with the heat transfer and carry heat away from the system. Means that it's not very effective. So in this study, in this research, we try to propose a microchannel heat sink with a design that can provide sustainable cooling solution, which means that we can provide high cooling performance with cost-effective way. As I mentioned here, SES1, SES2, and SES3. Based on this main goal, we have two objectives that we achieve in this study. As we know that rig cavity structure is a potential design that can provide this or meet this sustainable cooling solution. However, the main problem is that the recirculation flow in the cavity area that reduce or eliminate or reduce the overall performance of the heat transfer performance. So the first objective of this study to minimize the size of the recirculation flow in the cavity area by using secondary channel geometry. And then in order to achieve the SES2 and SES3, we try to improve the overall performance of the microchannel heat sink at low Reynolds number. Means that we will use low pumping power and low coolant consumption. Generally, they have two techniques to improve the microchannel performance, active and passive method. But in this study, we focus on the passive method. in the passive method, we can group in the two group. The first one, we improve the micro channel performance by using micro channel design. And then the second method, improve the performance by using Coulomb properties. But in this study, we focus on the micro channel design. Okay, in this researcher try to improve the micro channel performance by using single passive method. But there are similar findings that we can found is that high heat transfer performance could be achieved with excessive pressure drop. Means that it will use high pumping power and cooling consumption. Means that it not achieve the sustainable cooling solution. We don't want this. Okay, in this study, this researcher tried to improve the microchannel performance by using hybrid passive method. Hybrid passive method will use 2 or more technique, single passive in single channel. But we can see there are some limitation. Most of the hybrid microchannel is seeing achieve performance factor less than 2.0 at Reynolds number of 450. Mean that most of the proposed design only achieve performance factor at high Reynolds number. Means that it will use high coolant and pumping power consumption. Okay, this methodology that we use in our research. At first, we do the simulation work, and then we conduct the experimental work, and we compare, and we validate the numerical result with the experimental work, so that we know that the numerical work can be used in the industry or in the future for reference. Okay, for the numerical simulation approach, we use single wall microchannel. Means that we use only a single wall microchannel to do the analysis. This is a conventional design or the base design. And then these other 4 enhanced microchannel heatsink. At the first 2 is a single passive method, and the other last 2 is a hybrid passive method. And the last one is my final design. Okay, for the geometry optimization, as I say in my second objective, we want to achieve the overall performance at low Reynolds number. So we do the parametric optimization. There are 3 parameters that we focus. The first one is angle of the secondary channel, location, and the last but not least is width of the secondary channel. For the boundary condition, at the inlet, with the inlet velocity we set based on the Reynolds number, and at the outlet channel we set to 1 atmosphere, and the inlet temperature of the fluid we set to 300 Kelvin, and we apply the heat flux at the bottom of the microchannel heatsink with 100 watt per centimeter square. Okay, before we go further analysis with the enhanced microchannel heatsink, we verify first the numerical approach by using the straight channel design, because we have a data of the straight channel design in the previous study. When we do the grid independent test, we found that 300,000 grid number is the optimal number that can provide accurate result. How we know that? We compare with the previous study, and we can see that all parameters shows the error less than 10%. So this is acceptable approach to analyze the enhanced microchannel heatsink. Okay, this is the result for the simulation result. The velocity distribution, streamline analysis actually want to investigate the effectiveness of the rib geometry in the proposed design or enhanced microchannel heatsink. And as we can see that when we compare between these 3 designs, TC, TCRR, and TCRRAC, we can see that by having rib geometry, it can reduce the recirculation flow in the cavity area. Surprisingly, by having the secondary channel geometry, it reduces further the recirculation flow in the cavity area. And besides that, by having the secondary channel geometry at here that connect between this cavity area, it generates rapidly the drain vortex formation. Means that it will increase the degree of fluid mixing in the straight channel and then improve the heat transfer performance. Okay, velocity contour analysis. What the purpose of this analysis? The purpose of this analysis want to evaluate the uniformity of the fluid region in the microchannel, because this uniformity is very important to ensure to reduce the velocity gradient so that we can improve the heat transfer performance. And we can see here that these 2 designs shows the most uniform velocity distribution compared to the other design. And by having the secondary channel geometry here, we can speed up the velocity at the side wall of the cavity. Means that we will reduce the velocity gradient at the side wall and then improve the heat transfer performance in the cavity area. Okay, this pressure distribution analysis because we want to see the effectiveness of the cavity geometry in the enhanced microchannel casing. This we call a cavity geometry. This we call as a rib geometry. Okay, as we can see here that by having this cavity geometry in this design, it reduces the local pressure generated by the rib geometry due to the blocking effect. And then we can see here that by having the secondary channel geometry here, it reduces further the local pressure in the cavity area. Okay, this temperature distribution in the enhanced microchannel casing, we want to see the effectiveness of the combination between the rib, cavity, and secondary channel geometry. And as we can see here, TC microchannel casing, this design shows the highest temperature distribution, means that it's not very good for the heat dissipator, because we can see here that one of the reasons why these have the highest temperature distribution because they have recirculation flow in the cavity area. And then as we can see, CRRR, TCRR, and TCRR-SC microchannel casing shows the lowest temperature distribution compared to the other design. But CRRR microchannel casing cannot be used as a sustainable cooling solution device because it have high pressure drop. So we eliminate this design. If we compare between these two designs, we can see here that TCRR-SC shows the lowest temperature distribution compared to TCRR design. This is because of the dense vortex formation, as I mentioned before, and the uniformity velocity distribution. And the other factor that made TCRR-SC microchannel casing the best compared to the other design because TCRR-SC microchannel casing has the highest convective heat transfer area, means that you will dissipate or remove the heat efficiently. So so in this graph, actually, I want to consider not only about the heat transfer, but at the same time, I want to consider about the pumping power or the pressure drop. In the performance factor, actually, we will consider both parameters simultaneously. And as we can see here, all enhanced microchannel casing or proposed microchannel casing have a better heat transfer performance compared to the straight channel design because the performance factor is higher than 1. And then if you compare between the enhanced microchannel casing, we can see that the TCRR-SC microchannel casing shows the highest performance factor. And then as you can see here, TCRR and TCRR-SC microchannel casing reduce the performance factor reduced with the Reynolds number. Even the friction factor between the TCRR and TCRR-SC show the similar value, but the problem is the Nusselt number of the TCRR reduced with the Reynolds number because of the recirculation flow in the cavity area, as I mentioned before. And then even the Nusselt number of CRRR microchannel casing shows increase with the Reynolds number, means that it's better in the heat transfer. But the problem is the friction factor in the CRRR microchannel increase rapidly with the Reynolds number. This is because of the blocking effect in the small area, as I show in the figure just now. Okay. As I show in the methodology, we have 3 parameters in the parametric optimization: secondary channel angle, secondary channel location, and secondary channel width. At first, I want to show the secondary channel angle. And as we can see here, secondary channel angle of 45 degrees shows the highest performance factor compared to the other angle. This because, as we can see here, secondary channel angle of 50 degrees shows the lowest temperature distribution compared to the other design. That means it contributes to the overall performance of the microchannel casing with the secondary channel angle of 45 degrees. And at the highest Reynolds number, 400 to 800, secondary channel angle of 60 degrees shows the highest one. This because, once again, we can see here that secondary channel angle of 60 degree shows the lowest temperature distribution compared to the other secondary channel angle. That means it contributes to the overall performance or performance factor. Okay, this second parameter, which is the secondary channel location, and as you can see, at low Reynolds number, same with Reynolds number 100 to 400, secondary channel angle of 35 achieved the highest one. Because of the secondary channel location of 25 micrometer shows the lowest one compared to the others. And at the highest Reynolds number, secondary channel location of 40 micrometer shows the highest one. This because once again shows the lowest temperature distribution compared to the other two secondary channel location. And for the last parameter, which is the secondary channel width, we can see here that the wider secondary channel width show the highest performance factor. Why? This because we can see here the secondary channel width with 50 micrometer have a wider secondary channel geometry. It means that it will allow fluid to flow to the adjacent channel, more fluid to flow to the adjacent channel, so that it will increase the degree of flow mixing and improve the heat transfer performance. And as a proof, we can see here, secondary channel width of 50 micrometer shows the lowest temperature distribution compared to the others secondary channel width. So as after the optimization, we can see here that after the optimization, the performance factor increased to 2.09, and even at low Reynolds number 440, the performance factor is higher than 2.0. Means that it's better because this design have a best performance factor compared to the previous study, because in the previous study, no study shows or no study obtained performance factor higher than 2.0 at low Reynolds number of 450. So if we compare between our proposed design with the existing or the conventional design, we can see here that by using our design as a cooling device, we can reduce the pumping power consumption by 83.7%, and the coolant consumption can be reduced by 68.9%. And at the identical pumping power, we can reduce the thermal resistance by 41.3%. It's very, as I mentioned before, we can provide the best cooling device with the cost-effective way. The cost-effective way, we can reduce the pumping power and coolant consumption. So as a conclusion, we can see here that by using the secondary channel geometry in the existing or in the previous design, we can generate the Dean vortex formation rapidly. Means that we can increase the degree of fluid mixing at low Reynolds number. Means that it will improve the heat transfer performance with less coolant and pumping power consumption. And then by using the secondary channel geometry in the rig cavity structure, we can remove or eliminate the recirculation flow in the cavity area. Means that we can improve the overall heat transfer performance. And the most important is the performance factor or the overall performance can achieve at low Reynolds number of 450 with the higher performance factor, which is greater than 2.0. Okay, thank you. That's all from me. I pass to my my supervisor, Dr. Naasadi. Thank you.
Thank you very much. Thank you very much, Dr. So that's all presentation from our side, Prof. So pass back to you.
Okay, thank you, Professor Aswadi, and I don't know how to call one Muhammad Arif bin Aziz Japar. Is it correct?
Yes, correct.
Yeah. Okay. Thank you very much. I think it's very interesting presentation. This is about heat transfer, of course. Okay. For the audience, maybe all of you or one of you have so many questions, please. Okay, before maybe I have so many questions for you. One, Muhammad Arif. Yeah.
Okay.
One of them is why did you use a laminar force convection cooling method in this research?
Okay, as I mentioned before, actually we want to make the sustainable cooling solution. If we use the turbulent flow, actually we increase the pressure drop. Means that we need to use higher pumping power, so it not make the sustainable cooling solution. Because as we know that in the new device, most of them are more compact, so we need a very small and compact cooling system. If we use turbulent, we need to use a high volume flow rate of the coolant. So we need to install high volume in the device. So we don't want that. That's why we focus on the laminar. Besides that, in the microchannel heatsink itself, we need to use laminar flow to prevent the leakage or something like that.
Oh, okay.
Okay.
Okay. Honestly, I have so many questions because I am from mechanical engineering, but we give Pak Samsudin Anis to ask a question. Please, Pak Anis.
Thank you very much, Dr. Rizky Fitri. And good morning, Dr. Nur Ahwadzi.
Good morning.
How are you? And also Dr. Wan Muhammad Arif. How are you? Good morning.
Good morning.
Baik, Assalamualaikum.
Waalaikumsalam.
Thank you for a very interesting presentation. I would like to ask about the development of micro channel heatsinks, MCHS. This is very easy. This is very instrumental in improving the performance of electronic equipment. And you explained that the hybrid MCSS designed with the cavity structure and with secondary channel geometry is able to increase transfer and also reduce pumping power consumption of about almost 84%. So this is interesting, high performance of the MCSS. So in this term, I have two questions. The first is, could you please explain what makes this case unique compared to others? Because the performance is very high. And the second is, what type of coolant is suitable or used in your work? Because I think the coolant also have play also a role in improvement of the heat transfer in this case. Thank you.
Thank you for the question. Actually, I can't get it, the first question, but I answer first the second question. For the coolant that we use is on water, because as I mentioned before, if we use a nanofluid or nanoparticle, we need to think about the stability of the nanofluid, because actually nanofluid is very difficult to use in the microchannel heatsink, because the first thing that we need to have by using the nanoparticle is the Brownian motion effect, because it will maintain the stability of the nanofluid in the microchannel. But the problem is Brownian effect is very difficult to create in the microchannel, in the micro size. So that's why we not use the nanofluid. And the second problem is we need to think about the how to dispose after we use the nanofluid. So in this study, we've only focused by using this distilled water, or water that we can get anywhere. That's why I mentioned this device is suitable for the sustainable cooling solution. First, because we can improve the heat transfer with the cost-effective way. And the second one, we just only use the water as a coolant. So it's very easy and easy to get anywhere. I think the first question, I'm not clear.
Okay, let me answer the first question, Prof. Okay, so the secret behind the success of this microchannel heatsink is the hybrid of passive methods, Prof. because when we do literature review, literature survey, many of the papers so far just consider one or two passive methods to improve the performance of microchannel heatsink. But in our case, we combine a few more methods in passive methods. For example, secondary channel. I think the secondary channel is very effective in mixing the flow between two channels. And because of that, the overall heat transfer performance can be improved. So the secret is the secondary channel, but the difficulty is the fabrication of the microchannel heatsink, because the size is very small, and then we need to create very small channel, and that is the difficulty. If we can get very good fabrication, even though we need to send to Australia to fabricate the microchannel heatsink. So if we can do it here, maybe we can cut the cost and we can further improve the performance of microchannel heatsink. Thank you for a very nice question, Prof.
Thank you, Prof.
Okay, thank you, Professor Nur Aswadi and Wan Muhammad.
Thank you very much.
Okay.
Thank you very much.
Okay,
Thank
thank
you.
you, Pak Anis.
Okay, thank you.
Yeah, I think because this presentation is very interesting, we believe we have so many questions for the audience, but unfortunately the limitation time, so forgive me to stop this question session. Okay, maybe for other question we'll discuss after the event conference with the keynote contact or through the committee. Let's wrap up our keynote session. Thank you, Professor Dr. Ismail Saad and Professor Dr. Nur Aswadi, Cesidik, and also Wan Muhammad Arif, all of the participants for the attending conference today. Next, we are going to closing the first section of keynote speaker on behalf of 11 Engineering International Conference 2020 to committee. I will return to the MC. Thank you.
Thank you to Dr. Rizky Fitri Naryanto for moderating the first event.
The next event is the awarding of a certificate, which will be carried out by the Vice Dean of Academic of the Faculty of Engineering, Universitas Negeri Semarang, Dr. Didik Prastianto, to Professor Dr. Ismail Saad from University Malaysia, Sabah.
Prof. Ismail Saad, many thanks for participating, for your very interesting keynote speech, and I hope that we can visit you in UMS, and maybe you can visit us again in Semarang. We also already sent some students from Faculty of Engineering to Faculty of Engineering UMS. So many thanks and great pleasure. On behalf of the Dean, I would say I would appreciate much your talk. Thank you.
Okay, thank you. Thank you very much. Thank you. Most welcome to visit us again.
Then the certificate will be given by the Vice Dean of Academic of the Faculty of Engineering, Universitas Negeri Semarang, Dr. Didik Prastianto, to Professor Nur Aswadi bin Cesidik, PhD from University Technology Malaysia.
Okay, thank you very much, Prof. Nur Aswadi. Maybe in the future we can strengthen our collaboration. I think that you already have a contact also with the Professor Anis, and maybe I can send my junior lecturer to take a PhD in your university. And we appreciate much and that you give a very great talk in this conference. Many thanks, Prof. Aswadi.
Thank you very much. Thank you very much, Prof. Thank you.
Thank you. Entering the next event will be guided by the moderator of the second session to Dr. Alpha Narendra. The time is yours.
Program Studi Teknik Mesin Jenjang Pendidikan S1 merupakan salah satu program studi jurusan Teknik Mesin Fakultas Teknik Universitas Negeri Semarang. Program tersebut mencetak lulusan untuk memenuhi kebutuhan sumber daya manusia dalam praktik rekayasa di berbagai industri. Program studi teknik mesin mulai berdiri pada tahun 2012 dan saat ini terakreditasi B oleh Badan Akreditasi Nasional Perguruan Tinggi. Program studi teknik mesin memiliki visi menjadi program studi bidang teknik mesin yang berwawasan konservasi dan bereputasi internasional. Dalam upaya mewujudkan visinya, terdapat 4 misi yang dilaksanakan oleh program studi ini. Misi yang pertama, menyelenggarakan pendidikan bidang teknik mesin, khususnya bidang konversi energi dan material, untuk mempersiapkan sumber daya manusia yang unggul, relevan dengan kebutuhan pasar dan berjiwa kewirausahaan. 2. Menyelenggarakan penelitian untuk pengembangan ilmu pengetahuan dan teknologi, khususnya di bidang konversi energi dan material yang ramah lingkungan serta mempublikasikannya. 3. Mendarmakan ilmu pengetahuan dan teknologi kepada masyarakat. 4. Menjalin dan meningkatkan kerjasama dengan stakeholder. Program studi teknik mesin didukung oleh sarana dan prasarana yang lengkap dan sumber daya manusia yang berkompeten di bidangnya. Tenaga pendidik atau dosen berpendidikan S2 dan S3 yang memiliki kompetensi di bidang energi, material, dan juga produksi. Riset penelitian dosen berbasis konservasi dan bereputasi internasional. Hasil riset tersebut berupa publikasi, jurnal, paten, dan juga produk. Untuk mengembangkan kualitas pendidikan pengajaran dan pengabdian kepada masyarakat, program studi teknik mesin menjalin kerjasama dengan perusahaan mitra, institusi negeri, sekolah, universitas negeri maupun swasta, dan universitas di luar negeri. Beragam prestasi telah diraih mahasiswa teknik mesin dalam mengikuti lomba-lomba baik tingkat nasional maupun di tingkat internasional. Mahasiswa program studi teknik mesin dinyatakan lulus setelah menempuh 144 SKS dan berhak menyandang gelar sebagai sarjana teknik.
Assalamualaikum warahmatullahi wabarakatuh. Nama saya Ahmad Sikita Pandi.
Kenalkan, nama saya Raisa Latin.
Perkenalkan, nama saya Amri Caksana dan rekan saya Bim Widyo Baskoro.
Nama saya Gunawan Muhammad Najibullah. Saya alumni Teknik Mesin Universitas Negeri Semarang tahun 2018. Ya, saat ini saya bekerja sebagai Performance Supervisor Power Plant di PT Merak Energi Indonesia. Banyak ilmu yang saya dapat selama saya kuliah yang dapat diterapkan di pekerjaan saya. Ayo gabung dengan Prodi Teknik Mesin Universitas Negeri Semarang.
Teknik mesin, ya satu.
Universitas Negeri Semarang merupakan perguruan tinggi negeri yang terletak di Kota Semarang, berlokasi di daerah hijau, Kecamatan Gunung Pati. Fakultas Teknik Universitas Negeri Semarang memiliki 14 program studi. Salah satu di antaranya adalah program studi S1 Teknik Elektro. Program studi S1 Teknik Elektro Universitas Negeri Semarang telah berdiri sejak tahun 2016 dan sekarang telah mendapatkan akreditasi B. Program studi S1 Teknik Elektro mencetak lulusan yang berkarakter mulia, berwawasan global, dan mempunyai integritas serta kompetensi yang mampu mengelola secara optimal sumber energi bersih dalam mendukung kebutuhan energi listrik. Untuk mencapai tujuan tersebut, program studi S1 Teknik Elektro memiliki sumber daya manusia yang cukup memadai, sejumlah 13 dosen dengan 4 orang dosen bergelar doktor.
Program studi teknik elektro S1 UNES memiliki visi yaitu menjadi program studi berwawasan konservasi khususnya dalam pengembangan energi bersih dan bereputasi internasional.
Untuk menunjang visi tersebut, program studi S1 Teknik Elektro menyediakan beberapa fasilitas seperti perpustakaan, laboratorium komputer, laboratorium manajemen energi, laboratorium mikrokontroler, laboratorium kendali dan PLC, laboratorium elektronika, laboratorium digital, yang dilengkapi dengan peralatan digital storage oscilloscope, modul handbag electronics, vector network analysis, power analyzer, solar cell trainer, motor trainer, dan lain-lain. Kami menjalin kerjasama dan mengikuti berbagai kegiatan kejuaraan di tingkat nasional maupun internasional. Pada tahun 2001 sampai 2003, embrio program studi S1 Teknik Elektro Universitas Negeri Semarang telah berjalan di bawah pemayungan Universitas Gadjah Mada dan telah menghasilkan lulusan di berbagai aspek pekerjaan.
Saya merasa bangga sebagai alumni di universitas tersebut dengan dosen-dosen yang mempunyai kompetensi yang bagus sehingga mampu menghasilkan alumni yang punya dedikasi dan integritas yang tinggi.
Belajar di sana menjadi kenangan yang indah yang memberikan spirit untuk berjuang berguna bagi masyarakat.
Saya merasa bangga berkuliah di sini karena memiliki fasilitas yang sangat lengkap dan lingkungan sangat nyaman.
Teknik Elektro Universitas Negeri Semarang adalah pilihan yang terbaik.
Bagi kalian yang ingin meneruskan studi di Universitas Negeri Semarang, khususnya Prodi S1 Teknik Elektro, kami tunggu kedatangannya. Elektro Jaya.
Elektro Jaya.
Assalamualaikum warahmatullahi wabarakatuh. I'm Alvan Narendra. Today we will introduce Prof. Ong as the third presenter, and then Mr. Agung Budi Wirawan. I'd like to introduce Prof. Ong. He is currently appointed as professor at Future Technology Research Center at National Yunlin University of Science and Technology and adjunct professor at the University of Technology, Sydney. His research interests are under general umbrella of renewable energy system, energy and fuel, green technology, environmental sustainability, and waste management. He has published more than 200 high-impact SGI journal papers with H index 50 on World of Science. He is invited and delivered several plenary, keynote, and invited talks at international conferences. He is listed as highly cited researchers, which is super, by Clarified Analytics in 1999 and until 2021. In 2018 and 2017, he received the Malaysia's Research Star Award, Frontier Research, and in 2016, received the Malaysia's Rising Star Award as Young Researcher by Ministry of Higher Education and Clarified Analytics. Currently, he is associated editor of Critical Review in Environmental Science and Technology. And the second is Alexandria Engineering Journal, Energies, and IPREM, as well as editorial board member for few other journals. Prof. Ong will deliver a presentation with title of Bioenergy and Biochar conversion from microalga biomass waste. The abstract, maybe Prof. I think Prof. Ong will deliver the abstract. It's more proper for him. Prof. Ong, the chair is yours.
Yeah, okay. Yeah, okay for the kind instructions. So firstly, let me share my slide first. So first thing, can you hear me clearly?
I can hear you clearly, Prof.
Okay, yep. Thank you. Wait a minute, let me share my slide. Can you see my full slide?
It's okay. I can see your full presentation slide.
Wait a minute. I cannot see my own slide. Wait a minute. Sorry. Why I cannot see my own slide? How do now you can see my slide or not? Cannot. Okay. Wait a minute. Okay. So now you can see my full slide, is it?
Yes, we can see your slide clearly.
Clearly, right?
Yes.
Okay, yep. A very good morning to all of you. First of all, thank you for your kind instructions and also inviting me to participate this the 11th Engineering International Conference. So I'm the Vice Chair Ong. So today I want to share my research experience about the bioenergy and biochar conversion from the microalgae biomass waste. So before I start the topic, I want to show you this figure, the energy and water. As we all know, these two resources are very precious for human beings, for our daily life, because these two sources are limiting each and other. As we all know that the water is required, or we need the water to produce the energy. I mean, when the energy is produced, we need the cooling tower, we need the water in the cooling tower. On the other hand, if you want to produce the clean water, then we need the energy input. So these two resources are very precious and very important for human beings. However, these two sources are limiting each and other. So in this era, so what we going to do? in order to solve these two very important resources, because both of them are maybe running short in the very short future. So now the topic that we want to discuss today is more on the energy part, which is the energy consumption is very cross relation with the industrial revolution. Why I say so? During the first industrial revolution happened in around 1784, which everything turned to the mechanical production. We have the railroad and also the steam power for the train. So during that time, you see, for my energy consumption, there are no any data before 1830, but during that time, the biomass energy is increasing because we need the wood for the steam power turbine. And however, for the second industrial revolution, which happened 100 years later on, which is 1870, everything turned to the mass production. We have the electric power, then everything go to the assembly line. So during that time, you can see from this figure, the coal is increasing. We are no longer use the raw biomass, but we convert the biomass, the wood example, into the coal. Then the energy consumption keep increasing until the third industrial revolution, which happened around 50 years ago, which everything turned into the automation, electronics, and we have the computers that come out during that time. Then during that time, the energy trend is changing again, which everything shifts to the oil and gas. The demand of oil and gas is increased. You see, the curve is much more higher compared to 100 years ago. Now, currently, what happened here is the fourth industrial revolution, which is everything turned into the artificial intelligence, the big data, robotics. Then during that time, what would be the energy demand? How are we going to solve this energy demand? Because as per current day, so the energy consumption is mainly depend on the fossil fuel, which the total energy consumption is more than 13,865 million tons of oil equivalent in 2018. This statistic is come from the BP statistic review in 2019. Out of this energy consumption, the amount from the fossil fuel account more than 85%, as we can see here, which are from the coal, oil, and natural gas. What happened with this fossil fuel? There are two main problems. The one main very serious problem is this all fossil fuel will cause the greenhouse gas, because during the combustion, the emissions, especially the CO2 emissions, will be produced, which will cause the greenhouse gas emissions. Then at the same time, it will cause the acid rain and as well as the global warming. As we can see here, the total emission, the world emission is increasing domestically after the third industrial revolution and until now. So we need to find the alternative solutions for this, because our atmosphere only can absorb half of the total emission that produced, because we produce around 1.7 billion tons of CO2 annually. but the natural can absorb only half of this amount. Then the other amount will contribute to the, like I mentioned before, the acid rain and as well as the greenhouse gas and cause the global warming. So we need to find the solution towards to the low carbon renewable energy to help to reduce this emission, as well as to find the solution for the oil shortage as well. So from the engineering perspective, there are two main solutions. The first solution is to improve the energy efficiency. For example, if we improve the energy efficiency for our current power plant, for example, by 2%, that means the total 2% energy input will be reduced. At the same time, the 2% of the emission can be reduced. This 2% is very significant when we look at the overall the total energy production and also the emission produced. Then I give you a very simple example. What is the energy efficiency? However, previously, 50 years ago, we are using the incandescent light bulb. We just use the light bulb. the light intensity for the light bulb is very small. However, the energy consumption is very big. Why? Because the energy, 90% of energy will turn into the heat instead of the light. Then after that, currently, we are using the what? Fluorescent light bulb. Fluorescent light bulb, the light intensity is increased while the energy consumption is reduced. Nowadays, we shift into the LED light. We still using the same system. However, while using the LED light, the light intensity is further improved. Maybe we just need one LED light bulb to replace maybe 3 of the fluorescent light bulb, while the energy input still remain lower. So with this energy efficiency is maybe the faster way to solve the solution, to solve the energy problem as well as the greenhouse gas problem. While for the second solution, might be we switch to the renewable energy, such as the solar energy, the biomass energy, the wind, hydro, and other type of the renewable energy. So this one is might be another solution. So for the talk today, what we want to focus is the biomass biomass energy. Which I'm focused here is the biomass from the microalgae, which is the 3rd generation of the biofuel. So here I divided into the 2 studies. First is the thermal conversion of the biomass for the green technology application. In this study, we are using the microalgae as the raw material using the torrefaction process. As for the background, I think I already explained before that, because to gather the energy shortage, to find the alternative fuels to reduce the climate change as well as the global warming. In this study, the main purpose is we find the suitable technique, low carbon process, in order to produce the biochar and also the sugar production from the microalgae. So from the sugar production, we can further produce and convert it into the bioethanol. At the same time, for the biochar, we can study the thermal behavior of the biochar. For example, the biochar can be used suitable to use as a solid fuel or other applications. For example, the as a bioabsorbent or for the bio fertilizer. Then after that, we are further study what is the real application of the biochar based on the thermal behavior that we obtain. So yeah, basically our idea is to convert the biomass waste, whatever biomass waste that we can convert it. For example, this can convert the microalgae, as I mentioned before, which I will show you in details about the microalgae conversion with the result that we obtain. Or we can convert other type of the biomass, for example, the jatoba in Malaysia and Indonesia. We are using some of the jatoba as a source of the biofuel. Then after the jatoba is extracted, the biomass waste can be converted into the biochar as well, and other type of the waste, for example, the agricultural waste and waste oil or other type of waste. Then through the thermal conversion, the thermal conversion process here can be the pyrolysis process, the torrefaction process, or any type of process, then to convert into the biochar and see what is the real application can be used for the biochar. So as the background, why we want to convert the biochar using the wet torrefaction process? Because the biomass waste itself has a very low carbon content and energy content, which is not suitable to be used directly as a fuel or to be used as other application. At the same time, most of the biomass waste have very high moisture content. That's why it cannot be used directly as well. Then if we want to use the thermal conversion process, we need the drying process. So the drying process is very costly. And at the same time, the bio oil that produced from the thermal conversion process normally have very low chemicals and thermal stability with the high oxygen and water content. So they have the limited application. So in this study, what we do, we use the torrefaction process. Torrefaction process is one of the mild pyrolysis process. Why I say the mild pyrolysis process? Because is used the relatively low temperature, around 200 to 300 degrees C. While for the typical pyrolysis process, we need around 450 to 650 degrees C normally, or maybe even higher temperature. It depends on your application. At the same time, the dry torrefaction able to improve the calorific values, energy content. So while another technique which we can use the wet torrefaction process, or we call it hydrothermal torrefaction process. For this hydrothermal torrefaction process, we can use the biomass in the moisture form or in the wet form. From this wet torrefaction, we no need the drying process. So for this process, it can be extract the biomass in the moisture form without any drying process to save the cost for the drying. At the same time, we can use water or other substance as the medium. So in this research, there are three main objectives which I already mentioned to investigate the dry torrefaction, the wet torrefaction. Then we see what is the improvement. What is the improvement between these two processes? At the same time, we study the conversion of the bioethanol and also utilizing microalgae biochar as the absorbent for dye pollutants. So this is the setup for the dry torrefaction. We just use the typical tube furnace with the nitrogen as the flue gas, and to correct the biogas and bio oil. Then the biomass we are using two types. One is the microalgae, another one is Jatropha as varying temperature and also the holding time. While another state of study, we design this wet torrefaction reactor. So why we want to do the dry torrefaction is to compare what is the efficiency of our wet torrefaction process, as it is compatible with the torrefaction or not. So in this study, we can use the wet biomass directly without the drying process in this one modified microwave assistant process. Then with the control temperature as well as the control pressure. Then after the reaction, two types of product will be produced. Two types of product. One is the solid biochar, another one is the liquid hydrogen. So for the solid biochar, we can further analyze to the suitable application. For example, as I mentioned, it might be suitable for the solid fuel if the HHP achieve a certain level. While for the liquid product, we can further go through the fermentation process to produce the bioethanol. So at the same time, we will study the TGF-TIR, what is the thermal degradation of the biomass. So this is the two types of the species we are using. So to cut it short, they are the Chlorella ESP31, which is rich in the carbohydrate content. Another type is the Chlorella FSP, which is rich in protein. So normally the people culture this type of the microalgae to extract the protein content. However, after the extraction, the biomass waste, we need to go through for the other treatments. So for the first research outcome for the drying torrefaction, we do on the Jatropha oil and two types of the microalgae that I show you. It show that energy years is around 97% where we achieve with the HHP improvement of 19% at 200 degrees C, 200 degrees C for the Jatropha oil. While for the microalgae ESP, which is high in the carbohydrate content, the HHP will be increased up to 45% with the energy yield of 80%. So from this study, we can found that the dry torrefaction have less impact on the FSP, which is high in protein, microalgae and also the Jatropha, because the Jatropha is only increased 19%, which compare with the ESP 31, which is 45%. I mean, the impact is much more lesser from the dry torrefaction. While we change it to the wet torrefaction. In this wet torrefaction, we are using the water as a medium to compare with the three types of the acid, which is acid sulfuric, phosphoric acid, and sulfonic acid. And from the strong acid to the weak acid with the various acid concentrations. As we can see here, for the ESP species, the solid year is decreasing with the increasing of the acid concentration, while for the ESP they are almost similar. There are no any changing, and also for the solid year for the ESP, it is the year is much more lower compared to the solid years from the ESP, and this can be explained by what the thermal degradation or the wet torrefaction process have less impact for the ESP species, which is has the almost similar with the dry torrefaction process. Maybe the most of the protein remain. I mean, the temperature is not enough to degrade the protein content. However, this process are very suitable to be used for the ESP species. So while the HSP improvement, as I mentioned before, for the dry torrefaction, we can achieve 44% at 300 degrees C at 45 minutes. However, we are able to achieve almost similar result, which is 45% of the HSP improvement by only 160 degrees for just 10-minute reaction by using the microwave wet torrefaction process. And this one to prove one thing. First thing, the microwave reaction able to reduce the reaction time, and also the temperature significantly. While by using the acid as a medium, it can further improve or degrade or hydrolysis process will be occur during the process. So here, similarly, for the improvement of 40%, it can easily achieved by just 10 minutes of reaction 160 degrees, while for the dry torrefaction, we need to heat until 300 degrees C. I mean, the energy consumption are much more reduced. So similarly, for the ESP product, they have the similar HSP and not much changing. I mean, the effect on the wet torrefaction is not much impact on the ESP species. So from this, we can show that first, the wet torrefaction are the effective method and successfully convert to the biochar have the similar HSP. And second thing, we found that from the characteristic study, the ash content able to decrease when we perform with the wet torrefaction. I mean, by using the wet torrefaction, the ash content is can be further reduced. I mean, this one can prove that this is one of the green methods. Then after that, we also correcting the data for the wet torrefaction together with the sugar content, because as I mentioned, during the wet torrefaction, the liquid product will be produced. So in this study, we still using the ESP species, while for the second species, we change to the Chlorella SPGD, because for that species, it's proven that has a less impact. So we change to another type of species, but this species also rich in the protein. So from the first study, we proved that this one, the carbohydrate, because we have this carbohydrate, might be suitable for the further biodiesel or biofuel production or bioethanol production. So from this study, again, It's proved that the biochar is decreasing, which is have a similar result with the increasing of the acid concentration, while the reducing sugar. Here, another data is come out. The reducing sugar is increased with the improve of the acid concentration. This one to prove that the acid hydrolysis process it took place after we adding the acid. We can see that at the higher acid concentration, the total reducing sugar is optimum. This is very interesting result. Then for the total reducing sugar is optimum. That means what? That means the total bioethanol conversion might be optimum. However, our result will prove the different. So that's why there are something coming up. What is that? Because I didn't show here. Okay. Okay. At the same time, the FFM. Oh, this one is the second slide. This one is proof that the biochar have higher biochar. That means have less impact. This one have less impact on the chlorella SPGP as well. Similarly, because it's the total reducing sugar is relatively less. Only can up to around 15 grams per liter, but compare to the chlorella ESP is around 100 grams per liter. So this is the conclusion that I can make. So I think it's high conclusion. I go through that faster. So this is the further analysis. I mean, to prove that the chlorella ESP have the higher total reducing sugars, and can be further continue with the bioethanol fermentation. So now I want to see you to show you the result for the bioethanol fermentation. Before that, there are one interesting compound is produced. I mean, as a byproduct, which is 5-HHM. 5-HHM is produced. The 5-HHM also will be increased with the increase of the acid concentration for both species as well. As a byproduct, it is produced as a byproduct. However, when we further produce or doing the fermentation of the reducing sugar that we produce, it's found that the total bioethanol or total fermented sugar is a bioethanol content is increasing with the increasing of the acid concentration. However, at the optimum point, this point, the total fermented sugar is reduced, is at the minimum. Why? Because the 5-HM, we call the 5-HM content. 5-HM is a very useful application in the chemical industry. Has many applications. However, it is the toxic inhabitant for the fermentation process. So that's why make the fermentation process inactive at the optimum 5-HM process, because is already more than the limit can be tolerant by the fermentation process. Yep, it's same thing with the ethanol content. We convert this one into the ethanol content. We found that at the optimal 5-HM content, the total bioethanol concentration the minimum are reduced. This is due to the what? 5-HM, because it's the unfavored fermentation process for the bioethanol production, because the concentration of the 5-HM already reach the optimum tolerance for the yeast during the fermentation process. So this is the result. So the optimum result might be not the optimum of the total reducing sugar, but at 160 degrees C at 10 for 10 minutes. So this is a sustainable process for the bioethanol productions, because this one, the bioethanol is produced as the byproduct. So in our suggestions, we would suggest that in the future study, we need to extract or separate the 5-HM, because it is can be toxic inhabitant for the fermentation process. However, 5-HM has very important application in the biodiesel conversion as the additive, and also the can be used for the polymer or the resin deprosecutor. So in the future, we need to recover or separate up the 5-HSM before we further the fermentation process. Lastly, this is the last part, which the biochar, we further analyze the characteristics of the biochar. We found that the porosity is increased, which is suitable to be used as the bioabsorbent for the dye. This one, I think due to the time, I just quickly go through this one. From this study, we studied two types of the dye, which is the methylene blue and Congo red. For the PZC test, we found that the microalgae at the pH point or at the pH 3.7. That means for the pH more than 3.7, it is the negative charge, which is can attract or can attract the cation dye, which is the methylene blue, can attract the blue methylene blue dye, while less than 3.7 is positive charge. That means can attract the anionic dye, which is the fungal. While for the effects of the absorbent, we found that here effectively removal up to 80% for 1 gram, 85% for 1 gram per liter, while for the Congo grade it can up to 2 gram per liter with the removal of the 95% at the room temperature. This is the initial concentration and other parameters shown. And for the effective contact time for the various concentration of the dye, you can see that the removal are optimum at 120 hours for the methylene blue and 4 hours for the Congo red, which can reach the equivalent. And the biochar is a microporous absorbent with the pore diameter 0.65 nanometer, and also the optimal dosage for the methylene blue is 1 gram and Congo red is 2 gram, and they work well at the natural pH. I mean, we don't need to change the pH. Then the equivalent time is 120 hour and 4 hours for the methylene blue and Congo red respectively. And the this one is the interesting part, is the maximum absorbent capacity is 113 milligram per gram for the methylene blue and 164 milligram per gram for the Congo red. I mean, these microalgae are more suitable to be used for the methylene blue absorbent. This one I think I'll skip. So now the world are moving towards to the renewable energy to reduce the CO2 intensity by year 2015. So the biomass from the tropical biodiversification, especially from Malaysia and Indonesia, we have a lot of the biomass potential which can be converted into some useful energy or some useful byproduct. So it's important to develop a sustainable green technology that's suitable to convert the biomass waste into the renewable energy or other product. At the same time, we can solve the waste problem. So I think that's all for my sharing. Thank you for your attention.
Thank you, Prof. Ong.
Yeah.
What a great presentation. It's I don't know how to express. Is there any question for the participant? So, Prof. Ong,
yes.
During waiting for participant question. So, from your opinion,
yes.
Is it feasible for us to harvesting some algae and then create bioethanol or char for dye process in industrial?
Okay, for my opinion, so what our technology is do on the waste conversion. conversion, because the microalgae, the main purpose for the microalgae is they culture the microalgae for the certain purpose, basically for the medical purpose or pharmaceutical purpose, which they want to extract some useful compound from the microalgae. Then after they extract the useful compound, we found that the microalgae is a waste. Right? No matter we like it or not, we need to treat the waste. So the microalgae, it can be first thing like what I mentioned to be converted into the biochar and other byproducts. At the same time, the microalgae has the very high liquid content, which might be converted to the biodiesel as well. So what we doing here is to solve the waste problem. At the same time, it can convert to obtain some useful product, for example, the biofuel or other type of product, for example, the biochar for bioabsorbent, or maybe biochar for the biofertilizer can be used in the agriculture industry. So it's a natural fertilizer. So our main purpose is to solve this biomass waste problem, the waste problem. Yep, main thing.
Thank you. Mr. Samsudin. Okay. Go on, Mr. Samsudin. Anis.
Good morning, Professor Hong.
Yeah, good morning.
I am Samsudin Anis from Mechanical Engineering Department, Universitas Negeri Semarang.
Yeah. Nice to meet you.
Thank you. This is the very good presentation.
Yeah.
I think there are many information you presented in this session.
Yeah.
And this is about how to remove, for example, methylene blue and other heavy metals like that.
Yes, yes.
And could you please explain, because we know that there are many types of methods to remove the heavy metal from wastewater, for example. For example, liquid compared to liquid accretion, emulsion, liquid membrane, and this one about the absorption technology.
Yes, correct.
Thank you. Thank you.
Okay. Yeah. Thank you. So actually, I working in Taiwan. Actually, I'm from Malaysia. Last 2 weeks, I only visited the Indonesia.
Okay.
Yeah. Okay, thank you.
Prof. Ong,
yes.
Maybe Mr. Samsudin refer to the waste from what we call heavy metal. Is it possible that algae could absorb the heavy metal, and then the waste from the absorption could be another?
Okay, you see, yes, correct. It might be potential to remove the heavy metal and other pollutants from the wastewater. However, this type of the microalgae biochar that we produce might be not suitable for the heavy metal. We have test try to test the removal for the heavy metal. However, it has not effective outcome from the for the heavy metal. Means for our biochar that we produce, maybe other type of the biochar or the characteristic other type of characteristic of the biochar might be suitable, but this type is not suitable. Yep.
How about the other method, Prof? For example, emulsion liquid membrane like that. And maybe there are different process or performance.
Yes, this might be potential. I have another student. They producing their polymer or their membrane. So their membrane might be suitable to remove the heavy metal. However, they still starting to do this type of research. I couldn't give you much more result yet. Yes, the membrane, the membrane, the synthesis membrane that yes, it might be possible because we can design the membrane that's suitable for the certain for the removal of the certain heavy metal or certain pollutant, because we can design it the membrane that's suitable. Yeah, correct.
So this method we can remove or absorb simultaneously wastewater, for example, right?
Yeah. Yes, it might be possible. It might be possible. However, we need to see what is the effectiveness of the membrane that we produce. Is really yes, it might be possible. Maybe the efficiency or the effective of the removal is not verified. So that's why we need the further study to find the suitable membrane that can remove as much as the pollutant from the waters. Yeah, pollutant. Yes, it might be possible to remove all type of the not all type, most of the pollutant. However, what is the efficiency of it? Yeah, correct.
Yeah, thank you very much.
Yeah, thank you.
Thank you, Mr. Samsudin and Ms. I think, Prof, it will be great if interdisciplinary collaboration, chemical, electrical, as well as mechanical engineering.
Yeah.
Thank you for your presentation and your answer in QA.
Thank you.
I will continue to the next keynote speaker, Mr. Agung. Thank you, Prof. Ong.
Okay, thank you.
Mr. Agung will deliver the next presentation. Mr. Agung Budi Wirawan is an assistant professor at Civil Engineering Department, Faculty of Engineering at Universitas Negeri Semarang. He received his PhD from National University of Science and Technology in Taiwan. His bachelor and master degree is from Universitas Diponegoro, Semarang. His research area covers building information modeling, project scheduling, and project control. He is a member of the Universitas Negeri Semarang Artificial Intelligence Development Laboratory and the Procurement Unit. In AIC industry, he has a professional certificate as a professional in construction management. He has experience in handling procurement process by national and international standard. Mr. Agung Budi Wirawan, the floor is yours.
Thank you very much. Is my voice can be heard? Check. Oh,
okay.
So, okay. Thank you very much. Firstly, I want to express my gratitude to the committee of this conference for giving me the opportunity to share my paper today. Let me show my presentation. Is my slide shown on the screen?
Yes, we can see it clearly, your slide. Thank you.
Okay, thank you very much. Today, I want to share my paper about minimizing idle equipment using constrained programming for non-sequential linear construction project. So this topic is a little bit different than previous keynote speaker, which is more natural science. And this paper is more management science, but it is applied on the civil engineering field. I think by minimizing idle equipment, it means that we can improve the efficiency of equipment usage. So it has the same direction as the greener technology applied to the construction industry. My presentation today is divided into several parts. The first one is the background and objective, and problem definition, mind mapping based on the literature study, model development results, and the conclusion and future works that is maybe possible. Yeah, we start from what is scheduling. Actually, scheduling is just a series of related activities to achieve a project goal. However, its activities need resources to be finished. Because of that, scheduling of activities is closely related to scheduling of resources. On the other hand, in construction industry, we have linear construction project, which consists of many repetitive activities or repetitive works. Because of these repetitive works, they need the same type of resources. When we do not manage those repetitive activities well, it will have some idle resource in between. So in this paper, I try to present that a model to improve the scheduling performance that minimize the idle equipment. So that's why I choose the title, Minimizing Idle Equipment Using Constraint Programming for Non-Sequential Linear Construction Project. There is a keyword here, is non-sequential. Actually, linear construction, traditional linear construction project usually has a predetermined sequence of repetitive works. In this case, I will look deeper into road construction, road maintenance project, which doesn't really have a predetermined sequence. So in this case, we will look deeper into the non-sequential linear construction project. Because of that, I make some boundaries in these topics by mentions several points. The first one is this optimization model will be based on the road network maintenance project, which I already mentioned before, that road maintenance project has a characteristic as non-sequential linear construction project. The second boundary is this optimization model is applied to equipment usage or equipment allocation optimization, different than a high-rise building which has a typical floor type. Road maintenance project utilize heavy equipment. So this optimization model will focus on the optimization of heavy equipment utilization. And the third boundary, resources needed to finish an activity is expressed in unit days. So some optimization process has a smaller time period in construction industry, the smallest unit of time will usually is day, 1 day. So how we utilize resource usually based per day, not smaller than day, because it is too tedious to use a smaller unit of time. And the last the next boundary used in this topic is relationship between main equipment and supporting equipment is expressed in ratio between main equipment and supporting equipment. So in traditional linear construction project, resource used to finish an activity usually expressed in the term of crew. In this case, the crew will be divided into subcrew, which is main equipment and supporting equipment. In this paper, we will introduce the concept of equipment combination and configuration. Next is the problem definition. The problem we will try to solve here is road network maintenance project. So we can see that for road network maintenance project, it will consist of many road link. Each road link will have similar works compared to other link. So we can see, or we can consider that each road link is a repetitive unit which has similar works to other repetitive unit. So if we want to optimize the resource, we need to see, or we need to consider how to schedule between the same activity in different repetitive unit. But we also need to consider the precedence relationship between activities inside one repetitive unit. And this is the example project we discuss here for the equipment type requirement. We have 3 activity in each road link. The first one is asphalt stripping. The main equipment is asphalt milling machine and supported by dump truck. The second activity is asphalt resurfacing. The main equipment is asphalt finisher machine supporting by dump truck and pneumatic roller. And the third activity is road marking. Will be done by road marking machine. And the quantity of equipment needed by those works can be seen in this table. For example, for road number 1, the asphalt milling machine, we need 2 unit day of asphalt milling machine to finish the asphalt stripping work. And by it is supported by 5 dump truck to finish those 2 asphalt milling machine. So because asphalt milling machine need 2 unit day, so it will need 10 unit day of dump truck to support those asphalt milling machine. So this is the quantity requirement of the equipment. And this is one of the constraints, that resource is always scarce, resource is always limited. So this is the amount of equipment which are available to this project. From the literature review we had, I try to mind map how we look into the basic logic researcher has. So we try to dig deeper into the logic of scheduling and how it goes to the precedence relationship, to the network scheduling process, and go to the space-time graphical based scheduling. We start from the scheduling itself. That is basically just to arrange activity on time basis. Researcher is divided, not divided. Some researcher goes to the component and subcomponent relationship. So they focus to component and subcomponent relationship. So for example, if we make a concrete column, we need a rebar, a formwork, and a concrete itself. So concrete column is a component of a structure, and rebar, formwork, and concrete is a subcomponent of concrete column. If we look at this, we will look into precedence relationship. It means that rebar need to be finished before formwork can be started. And formwork need to be finished if we want to start the concrete pouring process. So by this method, we can calculate the schedule. Back to the focus of some expert focus on scheduling by this method. This method has strong relationship between one activity to the other activity. That is the advantage of this method. And this method can be easily applied to be automatically calculated by a computer program. So some researchers choose to see that way. So it goes to network-based scheduling. The application of network-based scheduling is critical path method, or project evaluation and review technique, or PERT. And the second part of expert see the efficiency of equipment allocation, resource allocation. They see from work similarities, and they go to resource continuity, and they go to the space-time graphical based scheduling. Space-time graphical based scheduling is efficient is good to see the resource continuity. So we can go further to the efficiency of resource allocation. However, this method doesn't have a good explanation about the relationship between one activity and other activity in the case of precedence relationship. So it is not easy to be applied to a computer program to calculate schedule. However, it has the advantage to see the resource allocation efficiency. Those scheduling method is LSM, linear scheduling method, and LOB, line of balance. So from that condition, we try to map further that we identify that construction project type consists of linear project and non-linear project. Both type project is not divided completely. They have some overlapping. Some non-linear project actually has some repetitive works inside, and some linear project also have some non-repetitive unit inside. So actually it is not completely divided. And for non-linear project, we go to the network-based scheduling, and for linear project, we go to the space-time graphical-based scheduling. However, when we see the optimization objective, we do not see the scheduling method. Actually, we go to the objective of optimization objective. The first one is resource allocation, the second one duration, and sometimes we go to the time cost trade-off. So the division between network-based scheduling and space-time graphical-based scheduling actually is not very clear. And if we see deeper into linear project, actually it consists of repetitive unit, And as we can see at the diagram, that inside a repetitive unit, it consists of sequential works. That is, because of that, we need the precedence relationship scheduling. On the other hand, between repetitive unit, we see the similar works, which needs resource continuity. So actually, we need a combination of LSM and CBM. Some experts approach this combination by two ways. The first one is by soft logic approach, which is utilize the precedence relationship more. And the second way is to go to the resource constraint approach. And this is how we try to approach this problem. We try to do optimization. We can go to deterministic algorithm or heuristic algorithm. Both algorithms basically need two orientation of process, two orientation of calculation. The first one is the process-oriented procedures that is basically based on the precedence relationship. And the second way is the efficiency-oriented procedures that basically goes to the efficiency of resource allocation. This is the highlight from previous study. Usually in resource leveling, they use a non-critical activity float to level the resource allocation. Multi-resource crew considering the lowest work rate. In this case, we consider equipment, combination, and configuration. Usually, resource profile are predetermined. So because before the optimization process, the resource profile used in an activity usually predetermined. But in this model, we will use a flexible resource profile, and it is not determined before the optimization process. And some of the way to maintain work continuity is to lowering work rate. And we don't use that. We use the flexible resource profile. For the model development, we will go to several parts. The first is model concept. The second one is decision variable. The third one is decision expressions. The fourth part is objective function, and the fifth part is the constraints. Why it is divided like this? Because we use a constraint programming method to optimize this problem. Why I choose constraint programming? Because it is easy to use. So by using constraint programming, we will be easily change the objective function. We will be easily change the constraint. We will be easily change the decision expression or the decision variable. Because in constraint programming, basically it is a declarative programming, not like the regular programming that is procedural programming. Declarative programming, we declare the mathematical expression that will become the objective function, the decision expression, the constraint, etc. So it is easier to create a prototype of model. Of course, if we want to further tuning it up for efficiency, we can go further into some other algorithm, maybe genetic algorithm or particle swarm optimization, but for prototyping the model, constraint programming gives the easiest way. If we want to tune it further, we will go to other algorithm. So this is the model concept. For optimization model, we consider the model features, we consider the project characteristic, and we consider the objective. And this optimization model will go to several scenarios to check whether the model responds well or not. And this is the resource dependency and equipment continuity concept. The traditional resource allocation will consider that different activity need different crew, only like that. But actually in road network maintenance project, sometimes different crew need the same equipment. For example, crew 1, it will need equipment 1 and equipment 4. And crew 2 also need equipment 2, equipment 4, and equipment 5. So equipment 4 is used by crew 1 and crew 2. So this one, sorry, this one will be the focus of this presentation. So what kind of condition can be because of that condition? So for example, is the same activity, different crew. For the same activity, which is asphalt stripping. So the crew 1 need 1 unit asphalt of milling machine and 4 unit of dump truck. Asphalt stripping 2 use 1 asphalt milling and 5 dump trucks. So same activity but different crew. The second condition is different activity, same equipment. So asphalt stripping compared to asphalt resurfacing. We can see that it also has the same equipment, which is dump truck. So those two conditions will create many more possibility in optimization process. So it is not like a traditional linear construction project to be optimized. It will go far beyond that because of those different conditions. And this is the idle equipment concept. Basically, idle equipment is the valley between the valley on the resource profile graph. And this is the model objective of this model. We go to 3 aspects. The first one is efficiency, and the objective become minimizing idle equipment. The second aspect is speed, and we go to minimizing duration. And the third aspect is resource scarcity, and we go to minimizing mobilized equipment. This is the decision variable. Basically, this is how many main equipment is allocated in which road and which day, something like that. And this is the decision expression. Actually, this is a regular expression. But we can see that in this expression, we cannot use a condition, assessment, and branching. Not like regular programming that we can use if, then, else. But in this expression, we cannot. So if we look at the equation 10 and 11, this is actually condition, assessment, and branching. But I need to express it to a mathematical expression here. So this is one of the drawback of constraint programming. So this is the objective function. The first one is minimizing idle equipment. The second one is the minimizing duration, and the third one is minimizing mobilized equipment. This is the constraint. We go through that, and we go to the result. We put the model into several scenarios. The first one is traditional LSM, which is the reference, the benchmark. And the proposed model will go to 5 scenarios. The first one, speed consideration. Scenario 2, resource scarcity. Scenario 3, efficiency. Scenario 4, efficiency and speed. And scenario 5 is efficiency and resource scarcity. This is the result. We can see that this is the traditional LSM. The duration is 27 days. The mobilized equipment is 24, and idle equipment is 78 unit day. And on the right-hand side, we can see those green rectangle. Those are the idle equipment when it happened. based on the equipment type. On the top right is the linear scheduling point of view. On the middle is the bar chart point of view, and the rest of the bottom is the resource profile. This is the result of scenario 1. We can reduce the duration from I forgot 27 days into 90 days, and we can see when the idle equipment happen on the green rectangle. The graph shows the linear scheduling method completely different, because it has some activities which are done in parallel. And the result of scenario 2, we have mobilized equipment 16 units. The third scenario, we go to idle equipment. We have 2 unit day of idle. So different than before, we only have 2 unit day of idle equipment. Scenario 4, duration 25, idle equipment 2. And scenario 5, mobilized equipment 26, and idle equipment is 2. So this is the comparison. We can see that the benchmark, the traditional linear scheduling method, shows that result. And based on the speed, we can reduce from 27 days into 19 days. For the mobilized equipment point of view, we can reduce from 24 unit to 16 unit. And from the idle equipment point of view, we can reduce in scenario 3 into 2 unit days. If we push further to combine the objective function between idle equipment and speed, and idle equipment and mobilized equipment, we can see that on scenario 4 and 5, we can get further optimization or further minimization. We can see that the duration is only 25 days. The mobilized equipment is 26 days, and idle equipment is only 2 unit days. So that is the result of this model, and we go to the conclusion. The conclusion, the optimization model succeeded to create optimized schedule with minimizing resource idleness as the main objective, combined with minimizing duration and minimizing mobilized equipment as secondary objective. And the second one is model with multi-objective model was able to optimize the schedule further by the secondary objective. And for the future work, this scheduling optimization can also be carried out from the point of view of the project economy. Cash flow of a project is not as simple as calculating costs to carry out its activities because of the time difference between material procurement, execution of work, and payment. That's all of my presentation today. I hope I do not take too much time. Thank you very much for listening.
Thank you, Dr. Budi Wirawan, for your presentation. Our next session is question and answer. For the participant, please raise your hand. You may ask as many questions as possible to Mr. Agung Budi Wirawan. For triggering the participant, I will ask Mr. Budi Wirawan. Have you considered the idle process as for cooling down the machine or cooling down the human as an idle? Is it a part of your considering or something else? Thank you. Please unmute.
Yes. Yeah, thank you very much, Pak Alpha, for the question. So in that model, we didn't consider about machinery cooling or human resource. In Indonesia, we call it healing, right? Human resource healing. But actually, yeah, maybe those conditions can be included. Yeah, we didn't consider that factor. But if we want to put that factor into the model, we can go by modifying the constraint. So we can make some constraint, which is maybe something like this. If the human resource already work for maybe 40 or 80 work hours, not work hours, 80 days. So he needs to cool down for maybe 2 days or something, maybe, I don't know. So we can create the constraint like that. Or if we have a crash program in finishing an activity, so the fatigue of the human resource will be higher. So maybe the time duration for the human resource healing is maybe shorter. So yeah, if we want to put those factors into consideration, we need to modify the constraint. Thank you very much.
So on your opinion, this is possible to put human limit or machinery limit as a constraint?
Possible.
Okay. And then you already mentioned about another algorithm, such as genetic algorithm. Is it replacing the equation on your your 15 equation? Is it possible to put as a constraint?
Maybe the term is not, the word is not replacing, not replacement, but re-expression. so the logic is the same, but how to express is maybe a little bit different. Maybe not much different, I think, but a little bit different because as I mentioned before, we had some decision expression which is assess the condition assessment and then branching, right? For if we go to the genetic algorithm, when we try to assess the condition inside those algorithm, we can go just using if then else. So the expression is different. Maybe if we need three expression in constraint programming, maybe in genetic algorithm or in regular programming, we only need one nest of if then else. So something like that.
Okay. Is there any participant who will ask Mr. Budi Wirawan? I think we can directly go to your office and make collaboration, right, Mr. Agung?
Pardon, I didn't get the last statement, Dr. Alpha.
Okay, it's okay. It's kind of joke. Okay, thank you. We had no more question from the audience, so we will move to our next session with Prof. Ong and Dr. Budi Wirawan from the MC. The floor is yours. Thank you, Mr. Agung.
Thank you, Dr. Alpha Narenda, for moderating the second event.
The next event is the awarding of a certificate, which will be carried out by the Vice Dean of Academic of the Faculty of Engineering, Universitas Negeri Semarang, Dr. Didik Prastianto to Professor Ong Hui Chuan, PhD from National Yunlin University of Science and Technology.
Okay, many thanks, Prof. Ong, for your great presentation. I hope that we can meet offline. We already sent many of our lecturer to your university to pursue a PhD, and then maybe we can also strengthen our collaboration by joint degree of the Mastership of Civil Engineering and for further collaboration. Thank you, Prof. Ong.
Then the certificate will be given by the Vice Dean of Academic of the Faculty of Engineering, Universitas Negeri Semarang, Dr. Didik Prastianto, to Professor Agung Budi Wirawan, PhD from Universitas Negeri Semarang.
Thank you for Dr. Agung Budi Wirawan for your great presentation, and I wish you success in your career.
Thank you very much, Pak Didik. Thank you very much for the opportunity for presenting in front of the EIC. EIC. It has been a great honor to me. Thank you very much.
Welcome.
The next event is break for an hour. We invite the presenters to rest, but we hope not to leave the Zoom meeting because it will be entered into each room by the co-host.